everyone can remembers the story of iRobot, right? The first, I would say, commercially success robot, really. Looks like we have our guest, Victor.
Yes. So we have here Victor. Are you there? Can you hear me?
Yep, I can.
Okay,
Hi.
excellent. We got him back, and we can see you. Hello, Victor. How you doing, man?
Hello, Ricardo. Hi. Good to see you.
Okay, excellent to have you here. So recover you. Everything is okay. How are you going? How many startups have you created in this weekend? Because you was a serial entrepreneur in robotics startups, so many.
None this week. Certainly none this weekend. But yeah. Sorry, guys. There's a horrible
Sound?
storm right over here. So if
Oh.
you guys lose me, just know that it's precisely because of that.
Oh.
But nevertheless, really happy to be here and sharing my 2 cents on the startup field and topic.
Okay, so then we have established that you haven't created any startups this weekend, along this week, sorry, but in your life, okay? So how many startups have you created?
A few, I would say. I personally, I'm not really fond of the serial entrepreneur.
Oh,
Sort of
sorry,
like,
I called
no,
you
no,
like
no.
that.
Never
Sorry.
mind, never mind, never mind. That's how it's called in industry. But I personally like to think more about it from the sense of sort of like embarking myself into fields of interest intellectually, especially in the field of robotics. That's pretty much where I have worked my whole career. And each one of my startups was actually trying to address a problem found either in the robotics industry or in the surrounding fields. And so far, the count, I think, goes as far as 5. I just invested in my 6th startup.
Wow.
Let's see how that goes. But yeah, a few.
Okay, yes. And I think that I can understand what you mentioned about not calling this as a serial entrepreneur, because you say something interesting. Is really, you didn't, if I understood correctly, you didn't create a startup just for the sake of creating startups. It's just because you had some passion about some field and you saw the opportunity to deliver to the world something that can be useful and that can help. Is that right?
Absolutely, Ricardo. And I think I speak for myself, but certainly many here listening to us right now know for a fact that you're one of those really good entrepreneurs. The reality is that I never really got interested into entrepreneurship or being a business person. Those were things that I sort of like found boring, and I still even nowadays don't become, or I don't feel very fond of those things. Not even now, but the reality is that eventually things, when you start solving problems, push you in certain directions, which make you an entrepreneur. But I never really got excited about the concept of entrepreneurship or related. I just got excited intellectually by problems in robotics, most of them technically related, and how essentially solving those problems could lead to adding value to end customers. That's sort of like what got me really passionate and how I started projects, so to speak, which eventually some of which became formal companies, some of which failed completely and never ended into anything publicly related, at least.
and but then what did you study in order to follow this path? So probably something in engineering, but what else? Because just by having engineering skills, you cannot build so many companies.
Well, you'd be surprised of how many great engineers out there are very capable of starting businesses themselves. But answering your question, as many of us, I became an engineer. I did 2 engineering degrees, computer science and electrical engineering simultaneously. I was a good student, so I finished quite promptly those, and then I engaged into the research path, which eventually got me into working into open robotics, but in the very old times. It was called at the time Open Source Robotics Foundation. Unfortunately, when I started my journey in robotics, the construct wasn't a thing just yet. So I couldn't take some of your courses, which I frankly find pretty exciting for the newcomer to robotics, and I very much vouch for it. But yeah, my path was a bit bumpy, I would say. So I knew about the lower layer aspect related to electronics and electrical engineering, and I got sort of like a good education on the higher level aspects related to computer science and systems architecture and related. So sort of like combining them both, I got the know-how required, or part of the know-how required to start building robotic systems and robot brains, which is something I've always been very fascinated. And that's how I got into this mess, I would say.
But then did you, so in order to create the companies, you have to upgrade yourself with some extra skills, because I know that you were managing, for example, several people. So I wouldn't say big teams, but I mean, definitely not small teams, for example. And then, so creating minimal viable products, finding the clients and so on. So how did you get all this knowledge?
You learn by doing,
By
frankly
doing, okay.
speaking. To be honest, I did attend some business trainings and some. Oh, wow, that's a storm. Sorry, guys. And frankly speaking, those helped out. But there's so much pollution in the startup world right now with what you should be doing, what you should not be doing. There's even degrees about entrepreneurship, university degrees, which I find hilarious at the very least.
Yeah.
My path was more related to the technology, the know-how under the hood on that regard. And then on speaking and finding my way, bumping into mistakes and speaking with customers. One of the things that you learn after a few years in industry as an entrepreneur, but also as an engineer, is the relevance of understanding your market, understanding your customer, and sort of like that is the hard path that got me into it. Sure, I mean trainings on business related matters help, but frankly speaking, when you're doing something so new, and frankly speaking, robotics is pretty new still to the
Yeah.
majority, there's not so many people that can support you with lessons or inspiring experiences. And I'm sure, Ricardo, you yourself experienced much of that as well. So,
Yeah.
frankly speaking, you just learn your way by doing, making mistakes, engaging with communities, sometimes the wrong one, sometimes the right one, sometimes you
Yes.
need to pivot.
Yes. Sorry to interrupt you. I just was
No,
nodding
no,
and saying yeah because I agree with you. Sorry.
no, it's
Yes. Yes. Okay. And then about the opportunities. Okay. You mentioned you have built several companies already, startups, and then for those you need to identify the opportunities or problems that you want to address in your startup. So how do you do that? Is just by inspiration or by thinking or by observing? How can you identify where to put the next egg? Let's say just
that's great. Yeah, that's a great question. In my case, it was mostly through my network and through experiences. So, as a roboticist, you get exposed to certain problems, and if you're willing to go beyond your area of comfort, the zone that makes you feel more comfortable, then there's a huge landscape of opportunities for roboticists, unexploited. So I've always been curious about those things that didn't exist and that those things that were not done but could be done eventually. I've always been fascinated by what robots and AI could do, and so that's sort of like how these opportunities came up. But there's a disclaimer into all of this, which is that we technologists, often the case, fall in love with the technology behind
yeah.
some of these opportunities and sort of like lose the business way. And that is something that if you listen to experienced company players or ex-entrepreneurs or people who have failed or succeeded with startups, often the case you listen to sort of like the same melody, which is focus on your market, understand your client needs, and go towards those, solve that problem. Don't fall in love with the technology you think it's going to change the world. Change the world by helping your clients.
That's a very good point. But what I see on the wall out there is just a few people doing this, what you mentioned, and many people focusing more on getting an investor and
Oh,
getting money for keeping the company alive. So how do you reconcile this? Is that because they are just faking let's say, the process, or is because this is one stage that is necessary in order to get to the other one with the clients? How do you explain this situation?
Well, I mean, certainly there are many reasons. I guess two relevant ones is the fact that the Silicon Valley pathway and marketing overall affected us all in the rest of the world too much. We sort of like bought the Silicon Valley way and missed the fact that in a huge way it's just a bubble, a huge bubble. That's one aspect of it. The second one is that it's easier to face investors, which often the case are fools. Fools, I mean, and please, nobody should get offended by
Yeah.
but most investors in the field investing in robotics know nothing about robotics, frankly speaking. I've spoken with hundreds of investors, and I'm still to find one that says reasonable things about the field itself. So often the case you see that those ones interested and active in the field are actually pursuing things into it and not just throwing money around. So the fact that investors are easy targets in a way, and it's easier to convince these fools to invest in your idea than face the market and solve a problem, makes many entrepreneurs just look for that. I mean, it's just way easier to just raise a few millions, cash out, and then take it easy, put yourself a huge salary, which is not in concert with the market, so to speak. Bootstrapping is really, really complicated, but statistics actually point out that those entrepreneurs that bootstrap are more likely to be successful.
Is it? Oh, okay. So that's good, because then that's our case. So we are going to get there. So I hope that this statistics is true. I hope. Okay.
Yes, definitely.
Yes, and then let me ask you about. So can you explain, because with this this conference and this interview specifically, we want to make the audience learn about the possibilities of how they can develop their career in robotics, and one is startups. Then maybe some of them, they don't know some of the terms. Then I would like you to help me on defining some of them that are important when you are creating a startup. And the first one is about the business model. What is the business model and why is it important? Which is related to your answer you just had.
Sure. In a nutshell, a business model is how you make money, in simple terms. Whether it's through offering services or via selling your product or doing robot as a service. There's a portfolio of business models in the field of robotics. What's important is that the way you make money, aka your business model, is something that scales, something that is consistent with the market, and something that ensures and secures you sustainability as an entrepreneur, as an individual, as a group, as whatever you're building.
And why do you say that is important, for example, that it scales? What does it mean that it scales?
Right. So one of the aspects that make a startup and not just an SME or a company.
Another company.
Go ahead. Sorry.
No, sorry. That doesn't make another company, right?
Yeah. So essentially, is what makes a startup and so special in a way is the fact that the business model should be to a certain extent exponential, and that means that it scales essentially in a non-linear way. So as you keep dumping resources into building up that business model and the technology related to it, you start getting more and more revenues and more profit. That is sort of like the discourse of startups. And it depends who you ask. There are many definitions of what startup is, but most people tend to agree that there's a pretty important technology component into startups, and that's what makes or should help them make and adapt to this exponential growth curve.
Mm-hmm. Okay, I think that then is clear for the audience what is the business model and what it means to have a business model that scales, allows you to scale. And can you tell us any business model that you have applied, that you have used in your companies, so the audience can maybe understand if they can apply themselves also, or they have to invent new ones?
So sure, absolutely. So across the experiences that I've had, One pretty common one is just selling products directly. So in one of my past companies, we were selling robotic kits, and in a way, those served as individual products. So you could log in into the page, select one of our products, put them into the cart, and just pay and fetch it. So that's a very simple business model that works out. Selling hardware in robotics is complicated business model, but certainly works out and has been working out for many companies for many years. Another business model can be what's often denominated just offering services. That's also something that some of my companies nowadays do, offering services in the form of robotics consulting, helping others realize their robotic creations or projects, or by offering added value to robotic setups. For example, one of my companies does robot cybersecurity. And so what they do is they offer a portfolio of services wherein they can help you secure your robots either via defensive or offensive actions. So those sort of like services are yet one more way to pursue business in robotics, another business model in a way.
So I would say that from what you said, that the second business model from the cybersecurity is more scalable rather than the other one about selling the robots on your webpage, right?
It depends very much of your product. It depends very much of the execution. So you could say that doing services might scale because it sounds closer to the customer and to the value you're adding to each one of the projects. But the reality is that offering engineering services requires you to grow your team in concert with the amount of engineering services you provide, which means that your human resources becomes a total mess because managing people is, trust me guys, more complicated than doing robots. That's, I guess,
I completely agree, 100%.
yeah, I guess most roboticists tend to agree that we like robots more than people. So I definitely sign that up. But yeah, that is one common thought: the fact that services are more tied to the client and to the value offered. But the reality is that for every new service, you need to sort of like develop a new intellectual property that you're offering to the customer, so to speak. Whereas when you sell a product, you design, implement, and build once, and then you sell it at scale. So some may argue that actually selling hardware and products in robotics is actually more scalable. Frankly speaking, every single case needs to be analyzed. My experience so far has humbled me to not make assumptions and to just dig deep into each company's business model and analyze carefully whether that has scalable potential or not.
Okay. And what about? So let me put you a question here. So what about the difference between software products for robotics rather than hardware products? Then would it be software? Would you say that software products are more scalable? Like, for example, an example of software product that for robotics, that would be those systems, those companies that provide telemetry data for your robots, so you can know what your fleets are doing and so on. So they install those servers in all the robots. So I think that this would be more scalable rather than in hardware. What do you think?
I wouldn't pinpoint, or I would not say one is more scalable than the other. It's based on my humble experiences, but frankly speaking, software is one of the unsolved aspects in the current state of the art in robotics.
Yeah, that's very good.
However, yeah, I know you and I shared this and have had lots of side discussions and are on the same page, Ricardo. But I'm sure I think you may agree also with the fact that even though it's one of the big problems, it is also increasingly becoming a commodity, meaning that many people just take it for granted. And some are just not willing to pay for a fleet management system if you already have some ROS, I don't know, packages that offer you those capabilities at maybe certain above or under value. I don't know, but many people has this sort of like attitude, and so I often speak with many software companies trying to sell robot software that very much struggle to make business due to the fact that the current landscape is changing. So one thing that I can convey of my humble experience to the audience is that I would just take a step back and analyze things from first principles and just don't take for granted what a robot is. In my humble opinion, a robot is a system of systems, a network of networks, if you wish, and robotics is the art of system integration, which intrinsically means you need to essentially put together software and hardware.
Mm-hmm.
So often the case, the most successful businesses put those two together into a business model that leads them to maximize the value they add to their customers and thereby to great scalability.
Wow, that's impressive. I think that you gave here some gold and here for the audience, because one of the questions that we are trying to solve here in this conference is, so I want to work as a roboticist somewhere, and then what should I do, software or hardware? And then the answer that is getting, in this case, from terms of business, because other previous speakers, they explain in terms of knowledge or applications and so on, but now you gave this explanation in terms of business. So is the business is in the combination of both, and do not get one of the parts only for like the part of your business that is only I'm doing only this part and then somebody else will do the other one or something like that, right?
I would agree with that statement. And frankly speaking, robotics is still, as a field, is still on its infancy. There's, if you critically analyze the companies in the robotics field, there are not so many huge robotics companies. And by huge, I mean, I don't know, a few thousand employees. There are not so many of those. So we are still on the very, very early stages, testing things out, testing ideas, and things may just take a turn in the coming years. Who knows? We'll see. But if anything, I'm definitely betting on a robotic solution, which intrinsically means keeping both things very tight together, software and hardware.
Excellent.
And of course, connected to the business value.
Excellent. Then you are answering here another of the main questions of the conference is now a good time to jump into robotics? Yes, you hear it. This is, yes, is a main super yes now. Okay, then for those that decide to jump into the robotics by creating a startup, can you define what is a minimum viable product?
Sure. An MVP essentially is the first prototype that shows value to your customers. That's I think a simpler way to understand it. Often the case, some people call an MVP that thing that you bring to investors and show it off to raise some cash. That's irresponsible. I think it does the job though. And honestly, I've never done that myself. I've been tempted. And frankly speaking, it wasn't like my network allowed me to that, because in robotics, there are networks and networks. But a real MVP is that thing that allows you to go and show it to a customer and potentially just convince that customer to start building a proof of concept deployment. That to me is an MVP, or a minimum viable product.
Yes, and when you say that it provides value to the customer, means that they are willing to pay for it, right?
Exactly.
Show the money. So otherwise, it's just a good wish. Yes. Oh no. Yeah, I like. Will you buy that? Yeah, I would. Yes, if it were perfect or something, I would. But then buy me one. Okay. No. Not now. That doesn't count as a minimum valuable product, right?
I don't think so. Some may disagree, but my experience says differently.
Okay, I do agree with you on this sense. And how have you validated? Because there is a concept of validating your minimum viable product, which means you show what you have and then you check if the people, they are willing to pay, they are willing to give you the money. So that will be the validation. So which methods or which strategies have you applied in order to validate your minimum viable product, MVP?
The market is the best validator ever. Just go hunt for customers and see what those customers have to say about your MVP. I mean, don't stay in your lab. Don't stay within your group of friends who believe that you're just making the next big thing in robotics, and then stay in that cave and come out year and a half with something that nobody wants or is absolutely not needed. Just face the market as early as possible. I often the case advise the startups I invest in or the ones that I get personally involved in to work on spirals. This is something that I learned very early during my roboticist career, which is the fact that you develop on a spiral something that is an MVP on a small spiral, as small as possible, that fulfills the basic requirements of your customer. And then you start making higher or bigger and bigger loops around that spiral concept and adding more and more features and more value. That is definitely the best validator, the market, and how I would approach that validator, which is in a spiral.
That would be the lean startup method, right?
Yeah, I mean,
Kind
you
of.
can call
Kind of.
yeah, I mean, sure, it is. It is, and like technically speaking, that's what the lean startup method is based on.
Okay, I'm just throwing some words over there because of the audience. They are new, and I remember when I was new, and then all those terms, what are you telling me? So now it's time that they start listening for that for the first time, or maybe it's their fifth time. So it's consolidating in their minds. So we are using this conference to teach them in the best way that we can. Excellent.
Makes a lot of sense. Yeah, my not to discourage anyone in the audience, but my only comment is that the lean startup method and all those books related to it pretty much focus on a software-centric business assumption. That is a very different reality from the one we live in robotics. It takes a significantly much more effort to build an MVP, a real MVP in robotics, than it does take in a purely software web-oriented business. So stay resilient, I would say, and that is what it takes in robotics.
Yes, definitely, yes. And also this connects with what you said at the beginning, which is about talking to your customers. You said this at the very beginning of the interview, that was a very important point for you. And that's what it's allowing you to do those spirals, because when you present the product, then maybe they will say, no, nobody will buy it. And then that's not the end. So that's now when you talk to them, but why? What's the problem? What is the characteristics that you would like, or which ones are you using for, or products are you using in order to solve this problem that my system is providing, or something similar? And then you get this feedback in order to improve the minimum viable product and repeat the process, right? That's the importance that you mentioned about talking to the customers, if I understood correctly.
Totally.
Okay, great. Then let me switch to another term. It's about creating the company and the team and so on. So how did you select your co-founders or the initial team members?
Good one. Well, when you start for the first time, typically you pull from your network, colleagues, friends, sometimes family members, the so-called three Fs, friends, family, and fools. That is how you select your co-founders and initial team members. And over time, you realize that that's not so bad of a strategy, because those groups are the ones willing to give you comfort in a very stressful first phase, wherein you need all the support you can get to go through that MVP creation process. So something that I personally did that turned out to be tough but very successful is reaching out to people I trusted, either good engineers or good business persons, even family members. I did work for many years with my family members. And it is a tough thing to work with friends or university colleagues or whatever. because often the case, the working reality is very different than the friendship or family reality. But if anything, a startup requires you to be very resilient, to resist against all that tough scenarios that you face. And the bonds that you have with friends and with family members are more likely to stay, let's say, in place versus all this adversity. So my personal experience was very successful, trusting on people close to me. But then as you grow your business, you definitely should diversify, go way, way beyond your network, try to, as often the case, it's said, hire people best or better than you, or just completely different to add heterogeneity to your team and ensure that it enriches the overall value in the team you're building.
Awesome. Awesome. And then, so there is one thing that is the company culture. Do you pay attention or too much, a lot of attention to that? So in order to enforce a certain company culture?
Absolutely, yeah. Yeah, I mean, often the case, startups are built around mission and vision. And upon those, you build up the company culture with key values and essentially things that all employees share. In a startup, you to work in a startup, you need to be inspired by what that company is pursuing. Otherwise, do not work or create startup, because there's plenty of companies out there who are willing to treat you much better than a startup might just be able to. Not because they don't want to. It's not that startups are meant to treat bad people. It's just that startups are very scrappy, or they should be scrappy by definition. And so struggling and suffering and working crazy hours is pretty much what's required in startups to kick off. So yeah.
Okay, and how do you enforce this culture from the new people that comes? Because maybe you have created this with your close friends and family or people that you trust that you mentioned, but then you start to grow, and then that's a problem because the new people that come, maybe they don't share those values. So how do you manage that situation?
You don't enforce it. That's my line. At least of course this is my personal interpretation, but I just don't enforce the culture and the mission and the vision to new hires. I just very carefully ensure during the interview process that these people is aligned with the company values and culture. And if that thing changes over time, which sometimes happens, activities in life from colleagues may change over time. And when that happens, then you just find a way to part ways in the most respectable way possible. Sometimes better, sometimes worse. But as I said, I've had many experiences, I would say, after quite a few years, wherein people's priorities just change. And it's not so much that the company needs to enforce it. It's more like people's visions about certain things just change, and you just need to be focused on ensuring that the company mission and vision remain focused. That is actually the role of an entrepreneur.
Yes, and then that's also a role of an entrepreneur of taking those tough decisions that it's up to here, and that's okay. No bad feelings or else, but it's up to here. And then you have to be mature enough to identify that situation and then take the decision. Because sometimes the other person doesn't even realize sometimes that it has changed, but now it was aligned with your company and now suddenly it's not for whatever the reason that happened. And then I think it's important in the entrepreneur to be able to detect those situations and say what you said is up to here. That's it.
Yeah, totally. And again, I know in some regions, in some social groups, it's fancy to work in a startup. But trust me, guys, startup is many things, and fancy is certainly not the one at the top. Startup is tough, it's complicated, it's sacrifice. there's plenty of jobs out there who are better suited for those ones looking to enjoy and have better quality of life. Startup is for those ones with the hunger to change things, to invent things out. And that implies often the case huge amounts of stress, and as Ricardo, you're pointing out, um, personal conflicts and yeah, those ones stay with you. So expect to be stressed if you want to become an entrepreneur, and make sure that you're resilient to high levels of stress, because you don't want to find that out later on.
Later, exactly. Okay. Let me ask. Can I ask you about which errors did you make while building your startup that you can explain, of course?
Sure. I mean, I can be very transparent.
Okay. Good.
Fortunately, after my experiences.
Because errors are quite examples of things for the people to understand what not to do, or maybe they are in that situation and they can identify that I'm in the same spot, so this can help me. The answer that Victor already has.
Yeah, absolutely. And this is one of the things that I really like about the American, North American, US culture. There are many things I dislike about US, but this one I particularly like, which is the fact that they get big from their errors, whereas we Europeans and in some areas in Asia, we sort of like are afraid of mistakes and
Yes,
errors.
shame.
So I can recount many of them. We don't have time to go through all of them, but I can point out a few that I think can be significant for the audience. The first one is gonna sound funny, but was actually listening to my investors and not my roboticist gut feeling. Um, so when you accept an investor into your board, into your company, essentially you're accepting a boss, and that boss has sort of like the handle of the company as much as you allow it as the key driving entrepreneur. So I sort of like made the mistake of pivoting completely in one of my past modular robotics companies, completely towards one demand that I had from an investor who was a corporate venture capital, meaning that it was the investment side of a huge multinational company. And so this huge multinational company had some sort of like crazy idea that was way far from the market about building robotic chefs and robotic cooking. And sort of like because they were pumping the money, we decided to pivot towards serving one of their ideas, building robot arms, and leave aside what was a very successful business model, building autopilots and robot brains for UIVs and drones. We had other great ideas, but we sort of like we made that mistake. I made that mistake, and looking back, I don't blame anyone but myself. But be resilient and be strong with your own thoughts. If they are validated by the market, then don't let anybody just drive you away from your thoughts and beliefs grounded in the market. That's one huge mistake that I made. A second, I think, quick error that I can share is mistaking friendship from professional relationships. I mixed those early during my career, and those got me very bad sort of like results. So make sure to remain professional and be professional on top of anything, especially if you're a leading party in a startup. Um, because your colleagues, your employees, whatever you want to call them, are really not going to look for the company in the same way you are. So make sure to treat everyone like you would like to be treated, and both be adamant on relevant things and flexible when required.
Excellent errors. I mean, the lessons from the errors. I mean, so that are very common. They are indicated in several books or several places where you are trying to learn how to better build your company. So those are errors that we have many of us. So if you can save that from the experience of Victor, go ahead and take it.
I mean, if I may, real quick, in a couple of sentences, one thing that often the case, like if I could go back, I don't know, a decade ago and restart my journey as an entrepreneur, I would love somebody to tell me the following. Guys, building the next generation of robots, whatever that thing is, if you want to build your business, your robot fast, if you want to do it fast, then do it alone. Don't build a team. Do it alone or with as little people needed. If you want to, however, go very far, then build a team. And those things can switch from one to the other one eventually at some point in time, but keep that in mind. That is something that I paid really hard. So just keep that in mind if it's helpful.
Wow, excellent. Then I think that I'm not going to ask you more questions now because you closed perfectly and with a very, very good advice. And I think it's very useful for the audience. So please, audience, listen and apply. Listen and apply. Then thank you very much, Victor. Now it's time for the questions from the audience. Thank you very much.
Thanks to you, Ricardo.
Let me check on the chat. There is another tab on the side that says Q&A. Then you can write your questions there or vote for the ones that are already there. And I will ask Victor the ones that are most voted. Let me see what we got here. And let me see. So, because in the meantime, I have some. Yeah, the problem is so we have here from Rodrigo. Rodrigo he's nailing it tonight. He's asking many questions to all the speakers. So the question is, what area of robotics would you say is currently getting the most attention in the business world right now?
Humanoids, I guess, and I am not very fond of it. But anyhow, leaving aside my personal opinion on that, I think it's humanoids. And if I should mention a second one, is definitely AI robotics. I definitely would focus on the second one, Rodrigo. That's my personal opinion.
Excellent. And a question from Vala that says, tell us about some networking places for robotics startups.
I mean, it depends very much of where you are from, your region. Frankly speaking, what works out very well is showing up in places like this one, the Construct. That gives you a huge network. Ricardo and his team have been doing a fantastic job for, I think, quite a few years now.
Thank you.
So you get to tap into a huge network digitally, online, and from your chair. And that is fantastic. So definitely this place. And then if you want face-to-face interactions, then just check out your local robotic clubs, check out local system integrator associations, check out if locally available ROS agrupations, ROS working groups, ROS national gatherings that can help you spread your network to a certain extent, but don't make the mistake to believe that ROS is the word of robotics. Just go beyond that. And of course, ROS is a crucial component, and it made the way and pathway for great successful companies like the Construct here. But just speak with customers, speak with end users, go to industry agrupations that include developers, but also end users and system integrators, and get to understand how the different stakeholders in robotics. So if I were to give you an advice, Balab, I would just tell you, go and sort of like flirt with the usual ROS groups and meetings, sort of like areas, but also just tap into the real world of robots out there and get to know what people is looking for.
And would you say that it is no longer required to go to California to build your robotics startup and to meet with the people that are alike in order to create a robotics startup?
Absolutely not needed. So I went when I was 24 years old. I went and started working in Silicon Valley as a roboticist. I was fascinated. I was walking the streets in San Francisco and the surrounding areas with my eyes completely open, believing literally that I was working into the cutting edge robotics technology and to the next thing. And certainly some of the things we did had an impact, such as ROS 2. I had the luxury of being one of the engineers building that up. But frankly speaking, a few years afterwards, I went to China, a few areas and places in China. And then I got to see the real cutting edge robotics. So frankly speaking, do not take for granted that things happening in California are the latest cutting edge things in robotics. You don't need to move from your chair if you want to be up to speed with the field. You have fantastic offerings right now, which we did not have at the time, such as the Construct. And by the way, I'm not hired by them. I just have full respect. And frankly speaking, I look up to what Ricardo has been doing all these years. I definitely think he's one of the folks that can give you guys lots of value.
Thank you.
But overall, just don't make the mistake to believe that you need to go to the valley. Don't.
Okay, another question from Andrea Perez. And he says, what do you think are the most important things to consider when creating a startup and you only have the idea of the service product you want to provide? So how to start? So I think that this guy has an idea and then doesn't know how to, what next step, what do I have to put my energy into?
Secure. I think the most important, I mean, robotics is an area that, again, requires you to build a physical value. A robot is a robot because it's composed by sensing that perceives the world, computation and cognition that allows you to essentially make sense out of that perception, and finally actuation, which is a way for you to interact with the real world. Without that real interaction, then that thing is not a robot. So you need to build the thing. So Andrea, much to my, or I don't mean to discourage you, but you need to build that idea into a prototype. And so for that, you need to secure the funds. You need money. That money can come from family, can come from friends, can come from you working part-time somewhere else, as many of us did, by the way. So you need to build that thing. And often the case, by the way, there are robotic clubs, there are universities willing to offer PhDs and masters for very low wages or none at all. And they are widely equipped. These places, universities are way equipped. So go there and prototype your idea and build it up.
That's very good. Yes, that's very good. Okay, another question. I think we have still time, right? Yes. So so here is a question from Ivan Boer that says, between robotics hardware, software, and services, where do you see the biggest potential for growth? I don't know, growth in which sense? In sense of the business, I suppose.
I mean, I would just, not sure if I understand your question properly, Ivan, but I will try to do my best answering, and I would just tell you that, again, robotics requires both hardware and software. Okay, so a proper robotics value demands you to assume you're going to have to be on top of all those things. Now, if you're asking me to whether it's better to sell hardware, sell software, or just do services, I just don't have an answer for you. I'm sorry. It depends very much of what you're really trying to sell on each one of those areas respectively. I know very successful companies in each one of those buckets. The one that I think is the most challenging one is software. But frankly speaking, that's the one wherein if you get it right, the scalability is mind-blowing. So tough, but huge opportunity.
Okay, I have one interesting here. I think that you can provide a very good answer to this one. It's from Julia Marsal. And then she says that if you have a hardware and you need some functionalities from the hardware which cannot be provided, so would you develop custom software applications to fix it, or would you change the hardware instead? So you need some functionalities on the hardware which cannot be provided by the hardware directly. So would you create some layer of software that kind of emulates or or creates this, or you would change the hardware?
It really depends on the cost repercussion of this decision and your budget. It really depends very much. The easiest thing is just to buy the hardware and get rid of the problem. If you have the budget to do so, then do it. Pretty much.
Yes.
If you want to add on the technical debt and continue maintaining software, sure, just build your own abstractions that fix up the hardware problem. But I personally think that the easiest path is pretty straightforward, and it's up to how much budget and resources you have available.
Okay, then let me ask you one last question from Rushav. Then he says, should I start working towards a robotics startup, or should I work in industry first?
Definitely work in industry first.
If he is asking the question, right? If he doesn't have the drive, I mean, if he is asking the question, it's because he's hesitant a little bit, and then maybe, so you need still to be more secure because of what you mentioned, because it's so tough. I don't know.
Yeah, I mean, I don't know. I don't know about your background, so I cannot really comment on that. But it does sound to me that that you don't have enough market experience, and if you do not have that, then again, work in industry, detect a need, make sure there's business, and then eventually, if you have the drive and the skill set, then do consider building up a startup. Sure.
Okay, excellent. Then I think that we can stop here. We have extract a lot of knowledge and golden pieces from you. Thank you very much, Victor. It's always a pleasure to talk to you. Thank you.
Likewise.
Are you going to attend the ROSCon this year? No.
No, unfortunately not. I sort of like have pretty big family things going on.
I know. So.
For the last period, and I'd like to keep focused on that. Having kids definitely is a big thing, and I'm taking it as serious as I can. And I think the conferences and those things can wait.
Okay. Then we'll have an opportunity to meet again in the future.
Definitely.
Thank you very much, Victor. A pleasure.
Thank you.
Bye-bye.
Yes. Thank you so much, Victor. Very nice talk. Very interesting. I hope you guys were all paying attention because, like as Ricardo said, there was a lot of golden advice here from a person with real experience here. Love the conversations in the chat, almost philosophical at some points. Very nice. Keep it up there. And
what was happening? I was not reading.
It was just a bunch of conversations there, quite interesting from Ruben and Ivo Georgiev. Very nice. Keep it up. Keep it respectful and everything. But this is what we want. We want people engaging in
Excellent.
our conference. So make sure to rate the speaker. You should see the box right now because at the end we will select the best ROS speaker based on your votes for this year's conference.
Mm-hmm.
Yeah, sure. So that's the exact way to support your favorite speaker. So now we know we keep doing some fun time.
I knew it.
Yes.
We couldn't imagine. We couldn't.
So yeah, it's the prize quiz again. So the winner is going to have another super sweat box with the I'm a robotic developer t-shirt, coffee mug, and the stickers. So it works the same. We're going to watch a 5-minute video about a Robotnik. Robot project by Robotnik, and at the end of the video, and we will see a question related to a product. So the first person who answers correctly will win the sweat box, and you may need to go to the page of the sponsor to get to the answer. So now let's watch the video, and you will see the next speaker in 5 minutes.
See you soon.
See you soon.
All right, guys, welcome back. Hope you got the answer. But before we announce the winner, let's get ready for the next presentation because it will be a hands-on learning session. So that means you're going to have to click on the open ROS button besides the speaker right above here. And again, this will open up a robot project. And don't worry if it starts, if it's loading for a while, just wait some seconds. And yeah, while we are waiting for the project to open, let's see who the prize winner is, Jazzy.
Yes, so the winner is Anderson Martin. Congratulations. Our
Yes.
team will contact you for shipping.
Yes, the proper answer are 4, which are the RB Kairos Plus, the Plus 5E, the Plus 16E, and the Plus 10E. So I'm just clarifying because people is putting some of the options there, but some of you miss one of them, so that's okay. So Anderson, congratulations.
Nice. This one was hard.
Yeah. So what do we have now?
State estimation.
Oh, yes, exactly. State estimation. And what is state estimation? It's about knowing in which location the robot is. So one raw way of getting the state estimation of a robot is, for example, by using odometry. But the problem of that is that odometry gets an error that is increasing over time, and it's usually not small. So for that, we can use Kalman filters in order to mix the odometry signal with the signals of other sensors that provide a better odometry, like IMUs, for example. So that is the subject of the talk now. So it is my honor to introduce you to our speaker, who is Thisas Ranhiru. He is an electrical engineering student, and today Thisas will be talking about state estimation with Kalman filters in ROS2. Please join me in welcoming Thisas to the stage. Hello, Thisas.
Hello, Ricardo. Thank you for the introduction.
Oh, my pleasure. How are you doing? Are you ready?
Could you hear me?
Yes, we can.
Thank you for the introduction, Ricardo.
Yes.
As he said, we'll be doing an introduction into robot pose estimation using the robot localization package with the box system. So in this case, we'll be answering the question, where am I? So before I talk about the system itself, let's talk about who I am. So who is this guy telling me stuff about this pose estimation, right? So hello, my name is Thisas. I am, as Ricardo said, electrical engineering major from the Rochester Institute of Technology. I also happen to be an intern at the Construct. You may have heard my name if you have been attending the open classes. I'm responsible for some of the newer notebooks in the ROS checks. So you can check out some of the work in learning robotics. For me, in terms of robotics, a lot of my experience comes in working in the AI and robotics club here at our university, which means I get to play with a lot of cool and interesting robots. And given this experience in playing with these robots, there are some challenges that come with robotics that are common to a lot of different types of robots. And one of those challenges is localization and in turn pose estimation. So let's talk about what pose estimation is, right? What is this robot pose estimation? What is a pose? So a robot pose is pretty simple. Think of it like a position in a chessboard. Or if you ever played Battleship, the position of your opponent's battleship, right? You give a simple coordinate, in a sense, like A12, and then the opponent knows exactly where you are. Similarly, it's a way of telling the system where your robot is in 3D space. So we have an X, Y, Z, and we have an orientation. The moment you heard X, Y, Z and orientation, you might be thinking, oh, I know what this is. This is odometry, right? This is the odometry message. And you're not wrong in the sense that the odometry message does have a lot of these, but Odometry itself is not the only thing that's used in pose estimation. In fact, using the robot localization package, we can combine multiple different types of sensors together to form one cohesive pose estimation. And there are several reasons why we would want to do this, and we'll be going through the advantages of why we would set up such a system by seeing the disadvantages of just relying on odometry. One of my favorite implementations of these types of full systems, you can see it's almost very close to the example image, is these food delivery robots. In practice, the goal is simple. You go from point A to point B. But in reality, when these robots are deployed to the real world, they need to be incredibly redundant. You don't want robots stuck in the middle of a road somewhere. You need them to reach their destination and come home. And for that to be possible, they need to have very robust localization systems, such as what the robot localization package will give you once you learn to configure it. You might have also learned this word that I've been saying called Kalman filters, right? Kalman filters in itself is a very critical part of robotics, but to be honest, if you ask me about Kalman filters, I could talk to you till tomorrow. But for the purposes of this presentation, we'll be thinking of them as a very simple filter. A filter, think of it like a system with a bunch of valves. We give it a set of inputs, right? We give it a set of measurements, and then it will perform a calculation, which in this case is a prediction. It will compare with our values, and then over time, it will produce a value of our pose based on our input values that is far more inaccurate than the individual values themselves. What do I mean by this, right? And let's see this in practice. Let's see this in a simulation. So for that, let's launch our simulation. By the way, there will be a lot of writing, and this is for the folks who are getting the ROS check, so the hands-on members. There's a lot of writing and theory that goes on, and if you're interested, please feel free to do the reading, it's quite interesting. And I have linked some interesting articles that I've gone through with the process of making this ROS check. So let's go ahead and launch the BotBox simulation and see what we're working with. So we can copy this command, and wherever it says execute in terminal, just open the terminal web shell. So you can see I have one open, and here we go. Then you can just paste the command and click enter, and it will execute the command. The simulation, which is the gazebo simulation, it will launch in this tab. If it doesn't launch automatically, you can click it. So I'm going to resize it here. Yeah, and you can see our gazebo is loaded. This over here is our tortoise bot, which we'll be working with throughout this session. This tortoise bot has a wheel odometry and an IMU on board. But this simulation is a little bit special from the regular simulations. It's because it simulates something that most don't. Now that we have it running, let's see what the topics are, right? Let's do a little bit of investigative work. ROS topic list, and we can see, excellent. This is a camera, interesting. We have the gazebo topics, and then we have an IMU, and we have an odometry. Perfect. We can double check if this is actually odometry by checking the topics information, and we can see, yep, it is of type odometry. So it's an odometry message. So now we have the odometry topic, right? We need to figure out, so we know because we're doing this this lesson that there is something wrong with the odometry. We can't just rely on odometry because it's not perfect. But we need to figure out why it's not perfect. What is the issue in this odometry? What is the error in our system? And to do this, there are many different ways of calculating this error. The most simple way, right, is if you have a real robot, even in the simulation, you can just put the robot down. You can tell the robot to move a certain distance. you can compare the distances, that is the calculated distance that it moved versus the actual distance that it moved. And from that, using a very simple formula, you can calculate your positional error. You can calculate this for X, Y, and then combine them together to form a one cohesive error. And then once you have this, if you're going to move around a lot, you can do this a lot of times. You can plot it out, and you will have basically a chart, something like this. The actual distance that you get is actually what's called as a ground truth. And this is something that you will see in a lot of research, in a lot of academia. This is what ground truth is referring to. It's the real life value, so to speak, of the value. And this is going to be a reference point for comparing whatever models that we have for pose estimation. Now, the big expensive labs, they have these cool motion capture setups that give them, centimeter level position accuracy. But for us, we actually have something better in this case, which is, since we're running in a gazebo, we can just pull from the gazebo. So you can see in the gazebo, inside that model state message that we saw earlier, that there is actually pose and orientation information that we can use. For this, we will create a new package called Odom Detective. So this detective is going to subscribe to these two values, and it's going to chart out, for one, our actual Odom and the actual ground truth. So this is going to let us compare the two values, and it also will calculate an error automatically, so we don't have to do the manual work. So let's copy this, paste it into our terminal. At this point, you can open the code editor, resize, and there we go. Until that loads, we'll go through this. First, let's create a detective.py script. You can resize it like this. Go into detective. Inside this, let's create a new file called detective.py. Let's paste in our script. Now, we won't go too much into this script because it's just a small tool to demonstrate the issue, but the code is there for the hands-on members, so they can feel free to check from there. Paste, perfect. Then we can just go through the most important part in this case, which is our calculating the error. So this is the simple formula that it uses to calculate the error, which is it calculates the difference between our ground truth and our Odom for X and Y, and then combines them together via a square root. So let's continue on with the setup of our script. Let's get the setup.py. This is what will help us, it'll help the package see where the executable that we created is, which is the Python file. It will also help the package see where the launch file is that we'll be creating. So let's create that launch folder. And inside that launch folder, let's create a new detective.launch.py. When you're creating these, make sure they're in the proper folder, otherwise the script can't see them. Okay. Now we'll copy this our launch file, and there we go. Here we just connect to our detective node, and we give a set of real life, and we have a parameter that says real life, which is what checks if it's in the gazebo or not. If it's set to true, then we won't check with the ground truth, and we'll see that later. And this is the Odom topics that we are going to subscribe to. So now let's build and let's launch this package. As you can see, no errors there. And soon enough, it should open graphical tools. If it doesn't automatically open, you can just click it and you should see our graph is plotting. Now you can see it immediately shooting up, but something you will also need to notice is look at the axis. It's very, very small, which means it's almost minuscule. That means the only thing you're seeing is really just the noise. And that's something you'll be seeing comes in important later. And this little dot is there for the ground truth and ODOM. It's just a dot because we haven't moved yet. So let's do that. Let's move. We're going to use the teleop command to move the robot. Let's move this over here, our terminal. Let's paste our command. You will see some instructions for how to move around. And let's open our gazebo window. Let's resize it so we can see where we're going. Let's do a little L shape, right? We don't want to move too much. If you have the hands on, feel free to play around with it. Okay, so we've done a very simple shape, and you can see our graphs being charted. So you can see as it starts out, the error is it's pretty much spot on. There's no issue. But the moment I did that turn, you can see the ground truth and the autumn started to deviate. And this deviation only really grew. And you can see that in the discrepancy. This spike is there because of this, I believe. But what you should be looking for is this round baseline, which is a zero, close to zero. And now it's at 0.1 1-ish. So you can see the autumn error actually spiked. And it's not really tracking well with our ground truth. So this is an issue, right? This is telling me that though there is some kind of problem that's preventing the autumn from being close to reality. Now, given that this is a differential drive robot, given that this is sort of like a turtle bot, and this is using wheel odometry, can anyone tell me what this source of error might be? Anyone in the chat? I'm looking at it right now. I think it's being updated. I don't think it's being updated. Ricardo, do you mind telling me from the chat if anyone can guess correctly?
Yeah, we're looking. This is wheel slippage, slip,
Oh,
wheel
yeah,
slippage.
yeah,
Yeah.
yeah, cool. I think it's Ivan, right? Okay, perfect. Wheel slippage. Now this will come in important later when we're doing the configuration for our EKF pose estimation. So let's make a package now that launches that, right? So let's close this down. Let's close that, and let's close this. To close stuff, you can just use Control-C, right? Simulation, we can keep running actually. Now let's copy paste this into our terminal, and that will create the new package for us, which is the BotBox EKF package. We need to create some folders. One is our inside of our BotBox EKF. Let's create a new folder for config. And inside config, let's create a new folder called ekf.yaml. Okay, perfect. Make sure it's in the folder properly. Now let's create a launch file, just like before, and inside a launch directory. So ekf.launch.py. If you are following along, the instructions are right here, so you can refer to it if you get a bit stuck or if I'm moving a little bit too fast. Okay. Now that we created these new folders, we need to let ROS know where they are. So let's modify our CMake lists. And this is basically just adding the launch and config directory to our final build. Now this is where the magic starts. The magic happens in the config, but this is where the magic starts. This is where we include our robot localization package, and it's pointing to the EKF node executable. Now there's two modes. There's EKF and UKF, I believe. There are two different types of filters, but for today we'll be using external Kalman filters. And we just name it EKF filter node, and then we have this parameter which is pointing to the config. And the other one is just use SimTime because we're running in a gazebo. Okay, so now that we pointed to our EKF config, let's start building our EKF config, right? This is the important thing. This is the controls for our valves that's working with the filter. So we're talking to the filter directly. So we'll get the header out of the way. This is just specifying these are the parameters. Now, first thing, we need to give the frames, right? Map frame and ORM frame. This is going to be pretty much the same in a lot of cases, unless you have some special naming scheme. The base link frame is going to be base link by default, but sometimes in some robots, it's base footprint. So you might want to modify that based on your TF tree. The world frame here is using ORM for this example, but if you're using something like AMCL, which is for like NAV2, for global localization, or if you're using something like GPS, then you'll want to modify the world frame to something else instead of ORM. Now our sensors. So we know we want to use wheel odometry and we know we want to use IMU. And I'll talk about why IMU in a bit. So, now, great. So for sensor inputs, you can have any amount of sensors as you want. There is no limit, but there are 4 types of message types that it supports, which is ORM, pose, twist, and IMU. When you want to list multiple of them, you just list the ORM, the message type, and an ID. So here I have ORM 0. So if I have another source of ORM, let's say I have like laser scan matching, I just say scan match or whatever the topic is. And I can combine them that way. Once you have the topics, then you need to give a config for that topic. And this might look a bit weird, but it's actually pretty simple. This is just an array of booleans. Think of them as like a big switch box, right? You want to switch on or off what data you're giving to the filter. So in this case, we're giving the absolute positions of X and Y and the yaw velocity, and everything else we're not giving to the filter. We're not letting the filter touch, which means the filter will get this message and then it will drop this information and then it will go to the filter. For a planar robot, we typically want our X and Y, which is our X and Y positions, and our X and Y velocities, yaw and yaw velocity. We don't really need Z, we don't need Z, because, well, we're not a holonomic robot, so we can't go in Z, we can't go in Y, and we're not a helicopter, so we probably couldn't go in Z, so we're going to ignore that. In case of these, if you can give as much of these as possible, that's really good, because in terms of the sensors that are useful, in terms of the values that are useful, giving all of them is the best case in this. But giving all of these values is not. And we'll get to why. Now, why are we adding the IMU? IMU seems so random. It just seems, why are we adding the IMU? Especially if you know something about IMUs, is that if you use them to get positional information, they are trash. You don't want to use an IMU for getting positional information because they just get more inaccurate with time. So why would you use an IMU? They are not really accurate at positional information. They get more inaccurate over time. So why would you use it? It's because the IMU is good at a few sets of things, and that's giving acceleration values and giving orientation values. Now, we won't really be using orientation aside from the yaw, but acceleration is useful to us, which is our X. So X and yaw, we will combine together with our odometry so that in cases like we measured before, where our odometry and our ground truth is starting to shift, we have another sensor that's telling it, like a wingman, that's telling it, hey, I know you said this, you're going this far, but I'm taking a measurement of acceleration of this much here in this point in time. So maybe it's better to go in this direction. And that will give you far closer to the ground truth than just using ORM. And we'll see this in action soon. So let's copy this initial configuration, right? And we'll go through what it is. So we know that we need X position, Y position, X velocity, Y velocity. So we're giving that. And then we're giving the X velocity, and we're giving the yaw velocity. And that's pretty much just for our RODOM. And for our IMU, we're going to give out our yaw velocity, and our acceleration. Now the IMU looks fine, and we won't touch the IMU for now. But for the ODOM, I want you to notice something, and it's that I give the absolute X position, Y position, and I also give the X velocity, and I didn't give the Y velocity. Now we'll put the Y velocity aside for now, right? But I give the X and Y. But really I shouldn't. And here's why. How are we getting this X and Y? Right? So if we think about the core issue, right? And it's wheel slippage. Wheel slippage, the way that the wheel odometry works is that they have an encoder inside of the motor, right? The encoder can calculate the velocity based on how many turns the wheel does in a given amount of time. So the encoder is very good at giving the velocity. So encoder knows at all times how many times the wheel spins, or how fast the wheel spins, really. But it doesn't know if the wheel ever touched the ground, right? You could be holding the robot up and the wheel could be spinning, but the robot will just think it's going forward. So this X and Y is actually calculated based off of this X velocity and Y velocity. So trusting it as an absolute position is actually very bad in this case, and we don't want to give it that. The reason why you would give an X and Y position is if you had something like GPS, where that absolutely gives you an X and Y. Or if you had some other method like ICP odometry, which calculated it in a different way to give you X and Y position, then you would fuse that together. But in this case, we don't want to do that. Another thing now is the Y velocity. We didn't give the Y velocity. Why? It kind of makes sense, right? It's not a holonomic robot. It can't go Y. So why would we give Y? But the reason we're giving Y is precisely because it can't move Y. When I set this to true, the odometry message will give 0.0 as the Y velocity. And that's important. That's an important distinction. When this gives 0.0, that tells the filter that it's absolutely not moving towards Y at all. Now we don't want to enable that for our IMU. Why? Because our IMU is always going to give some value of our Y velocity. Why? Because it has some level of noise inside of it. So the only reason why we would be seeing an acceleration for Y is because of noise. In most cases during normal operation. Unless you maybe like slammed your robot to the side, like you wanted to harass the robot, you would never get a Y velocity or Y acceleration. So it's best to set this to false in this case. So now we have our setup, right? We have our setup, our basic setup. There's one other thing, important side note, and then a very important thing. An important thing is the covariance matrix. There are two sets of covariance matrix. One is your process noise covariance and your initial estimate covariance. Think of this like as the gains in a PID control, right? These are things that you can tune to make the system better. These are typically not things that you tune when the system is not working. This setup in and of itself should make sure that the system is working. Once the setup is working for you and you want to increase its performance, then you start tuning these values. Not all of these values. You see this diagonal here, and that corresponds with your XYZ, etc. You can change the values here and here as well.
Thisas, 7 minutes to go.
Oh, right. So the next thing is we'll set it to 2D mode. We'll put it up here. This will make sure that the robot, the system ditches anything that's unnecessary for 2D. It will ditch everything that's unnecessary for 2D operation, which is like our pitch and our pitch and our role, just because our robot's never going to go those directions. So let me rebuild the package. Right? Okay, perfect. And now our EKF's running, and now we will run our detective, and let's run our. Okay, perfect. Now you can see the autom filtered, and ground truth. Now let's run our keyboard, and let's look at our simulation. We'll do the same exact movement. Probably not as precisely, but that's okay for now. Okay, close enough. Okay. So something you'll notice is that immediately the autom filtered sticks a lot closer to ground truth than autom is, which means it's a lot closer to the reality than autom is. And you can see that also with the autom discrepancy, which means our error in the system is much lower with our autom filtered than a regular autom. Now that we know our filter is working in the simulation, let's try it in real life. Because why would you want to test it in a simulation when you can test it in real life? And that's because this simulation is special because we have an exact replica of this simulation running in a real robot, in a real setup at the construct in Barcelona. And we'll be connecting it to it now. So our box robot, and we'll be connecting it to it. Okay, so this is not sponsored, but this robot kit that you can buy for education, it comes with these 3 of these robots that you can use. Okay, let's resize that. It comes with 3 of these robots and the full environment. So if you wanted to teach something, maybe test out an open class on a real robot in your own labs, then I would suggest it. And just like that, let's test our system, right? Enough talking. We'll do a small modification because the topic is different on the real robot. Okay. And now let's build and run the package. Okay, perfect. It's running. Now, if we ROS topic list, we can see with topic list, we can see our new filtered topic. Perfect. Okay. Now we can run our detective in real life mode, which means since there is no gazebo, we'll be just comparing the 2 topics together. Okay. And just so we can see a little more information, we'll be launching Arvis with another config that will show the 2 sources of odometry. Okay. Now that we have it running, let's move our robot around and let's see how our system reacts. Demo gods, please answer my prayers. Let's see it. Let's do the same shape on the real robot. We'll do a small turn here. And then we'll run. Okay. Now let's see our gazebo. And what you will see is right now it's almost exactly the same. So if I turn one off and turn another one on, it's in the same exact position. This is mostly because in real life, the odometry is actually not as bad as in the simulation, but we can still move around more and see more features that our filter gives us. Okay. Okay. So you can see the catching up. The red is our filter, and the green is just the autom. You can actually see small dots. It's not very visible here, but you can actually check the covariance of the 2. And this is something that is done by the Kalman filter, which is combines the covariances together, so you can visualize that. Okay, I think that sums up pretty much the basics of Kalman filters. Ricardo, if you have any questions, I think we can move on to that.
Excellent, Thisas. So thank you very much for your presentation. A big applause to you. Excellent. The people here in the chat were saying that this is awesome and very dense. So we need more time with you in order to understand all the knowledge that you have put in there. But now it's time to questions for Thisas. And as you know, there is a Q&A tab here on the top, on the side of the chat, where you can put your questions or also to vote for the ones that somebody else has done. And I will ask the most voted ones to Thisas. By the way, how is pronounced your name?
Thisas is okay.
Thisas. So, okay.
Yeah.
We thought that you pronounce it in a different way. Okay, no problem.
No, it's okay.
Okay, great. So, no problem. Then, let's go. Let me ask you a question. In the meantime that they are putting the questions there and voting, my own question is, which other sources of state estimation can be mixed using the robot localization package? Because here you have mixed the odometry with the IMU, but what else can we add into those Kalman filters?
Yeah, so as I was saying during the setup, there's no limit on how many sensors, what types of sensors you can put in. It's just the limit is there on the 4 types of message definitions that you can put in, like odom, pose, IMU, and yeah. So there's like 4 message definitions that you can put in, but as long as your sensor can comply with the Rep 105 standards, then your sensor will work. So visual, odometry, if you're doing laser scan matching, if you're doing GPS, that will all combine together just fine.
Excellent. So then here there is one question from Josh Shewe that says, how to use robot localization with navigation too? So how can you combine this?
Good question. So remember when I was talking about the map frame, right? And I was saying that it's ODOM for now, but if you're using AMCL, you can change that. So yeah, that's where you would modify that. You can combine it to work with AMCL so that it fits in with the rest of your localization stack. If you are looking for how to configure this exactly and doing the full stack, I suggest maybe doing one of the courses on robot localization at the Construct, because there is a very good course that you can follow. If you want, I think Alberto can link it on the chat.
Okay. Yes, thank you. But let me suggest a couple of ways. So about that, so one could be, for example, just the odometry that you are getting, you can feed into the AMCL, because now the odometry that you have filtered with, which combines wheel odometry and IMU, is like a better odometry. Then you can provide this better odometry to AMCL, so AMCL can use it for their computations of the proper localization. Then this localization will be better because the odometry is better data also. Another way is to combine AMCL with the odometry and the IMU on the same filter. And so you will have the combination of those two. So those are also two possible ways of combining. And then I have a question from Angel Lopez that says, are you aware about Fuse package?
I wasn't until I looked it up. Fuse seems like a stack for sensor fusion.
No idea. It says, I have been told that the people who develop robot localization are encouraging to use Fuse instead of this, but the documentation was short a couple of months when I searched about it. So you haven't heard about Fuse?
No, a lot of the current like documentation and a lot of the current like tutorials and everything is mainly focused around robot localization, and that's just because robot localization was something that was big in ROS 1. So when that
Yes.
was to ROS 2, you can actually use pretty much close to the same configuration YAML for ROS 1 and ROS 2. Just a few things you have to change, I think. So that's mainly why robot localization is, I think, if you want to learn, it's no problem. You can learn with robot localization. The important thing is understand the concept of how the fusion works, and then you can apply that same concept to whatever package, you know?
Yeah.
So understand the basics and then move forward with there. I suggest, actually, if you want to work with localization, try to understand about Kalman filters, like how they work. Which is another course that's there in the construct. So if you want to learn more about Kalman filters, you can maybe visit that course. But
Okay. Then, but we'll keep an eye on that Fuse package because I also don't know, and then maybe it's interesting to jump into that. Then another thing that says, another question is, John Segway is asking, so how did you plot the data in real time?
Matplotlib, Python, just combine it together.
Yeah, but how are you doing this? So you have a subscriber to the topics, and then using.
Oh, for plotting,
Yes.
my implementation for plotting. Let me revisit that actually.
Yeah, actually, it's in the project. So if you have access to the
So I
project,
have
then
I have an update plot function that gets called from I have a timer. So the timer calls the update plot function, and that makes sure that that runs on a separate thread, and that's how I continuously update it. So the X and Y gets into a local not a local variable, but into the self.oram data, self.ground truth. I continuously update that array, and based off of that array, update plot pulls from that array to do the processing. It's not really global. It's not a global variable, but it's global to the local to the whole class. So you can see the init function. Actually, I can screen share this.
okay.
Probably.
Yes. So
Yes.
I think that showing it will be better than explaining or more clearer.
Yeah. Okay. So you can see the ground data, ground
No,
truth,
wait,
and errors.
wait a second because we cannot see yet. Sorry, it's in our location. Can we show the now we can see your screen.
Okay, perfect. Okay, so you can see here that I define 3 dicks. One is for the bottom data, one is for the ground truth, one is for the errors. And then what I have is I have a callback called update plot that gets run on a timer. In this timer, I have this small script which basically sets the label. It adds the data. So for each thing in ORM topic, it plots it, and this continuously runs on a loop. So you can see where it gets flashed on the canvas. This took a little bit of debugging. It's a bit of a pain, but it kind of works. I think for the people who have access to the ROS check, they can feel free to copy the code. Or maybe I will reuse this in an open class so people can just take it from there.
Okay. And the next question from Ivan War that says, any note on visual odometry libraries for ROS 2? So are you aware of any of them?
For visual odometry in ROS 2,
Yes.
is a little bit sparse. You can look for ports of a lot of popular visual odometry libraries that were ported from ROS 2. But honestly, I wouldn't. Some of them are working, some of them are not. Especially if you're sort of resource constrained, I wouldn't go towards many. But the one library that I would suggest in many cases would be to go towards either OrbsLAN
Orbslam,
Orbslam
yeah.
3. Yeah, Orbslam 3 works in a lot of cases. Or there's this thing called OpenVSlam, which is pretty good. OpenVSlam, but it's less a bit stable. It was forked, and the fork is updated, but not the original repo. So there are some situations. There is a really good survey on GitHub, which goes through each of them because there are a lot. I put that in the chat.
Okay, excellent.
Okay, so you can see from there a lot of ROS1 options, some ROS2 options. If you just wanted to implement it for a project, just go with Orbslam. It's easiest.
Okay, great. One question from Sebastian Castro. How do all these tools do time synchronization? So it's all based on the ROS message timestamps, or do you have use any other tricks?
Can you repeat that?
Yeah. So how did you time synchronize the different odometries? So you can show them on this on the position at the proper, so they are matching one to another. And so if you are using just a message timestamp, you know that all of them, they have a timestamp, and or you are using your own trick. What's happening? Have we lost Thisas?
To combine that, it's based on the timestamps.
Oh.
So it.
Hello, Thisas, are you there?
Oh.
Yes, we can
hear
hear
me?
you. Yes, we can hear you. Go ahead. Yes, we can see you. So what about the timestamps?
It's based on the timestamp. It's based on the timestamp. So the filter will take the data in based off of the timestamps, and you can make the filter itself go at a specific refresh rate or specific like number of hertz. I think it defaults to like 30 or something, and it will use the timestamps to synchronize them. I'm not sure if it does exact synchronization or not. You would have to refer to the documentation for that one, I'm afraid.
Okay. Then thank you very much, Thisas. We don't have more time for questions. Thanks a lot again to our speaker. Thank you. See you around, Thisas.
Thank you, Thisas.
Okay, see you. Bye-bye.
Very nice presentation, especially the real robot part. Really love that. So, yes, dear attendees, now you should see the box on your chat in order to rate this speaker. So take a moment to do so, because remember, when we finish this conference, we will announce the best speaker based on your votes.
Absolutely. So before we see the next speaker, so I believe maybe all of you can guess what we're going to do now.
Oh boy.
Dear. No,
I think I know. I think everyone knows.
Yes, it's prize quiz time.
Oh, yeah.
Yes. The winner will get another super sweat box with the robotics developer T-shirt, mugs, and the stickers. So this is sponsored by the bot box by the Construct. And we will watch a 5-minute video about the bot box. So at the end of the video, again, you will see a question related to this. And the first person answers correctly will win this swag box. So you may need to go to the page of the sponsor to get the answer. So now let's watch the video, and the next speaker will hit back in 5 minutes.
See you soon, guys.
See you soon.
See you soon. Welcome back. Now let's see who is the winner. So congratulations to Sebastian Castro. So congratulations. Our team will contact you for the shipping details. So now let's get ready to be inspired by the next career advice.
Great.
So just one, small mention that the advert that appeared didn't correspond to BotBox. No, that's the one. Okay. Yes, exactly. Okay, thank you. Sorry, Jazzy, for interrupting. Go ahead.
Oh, it's actually me. I'll say, yeah. Well, great. Without further ado, we're going to move on to our next session, which is another expert career advice with Professor Jack Silberman and Ricardo, with insights on teaching and researching robotics at university. So take it away, Ricardo.
Yes, so here, thank you, Rodrigo and Jazzy. So teaching and researching in robotics at the university is a fascinating career path that you can also take. Because with the rapid advancement in robotics technology, many of you may be interested on pursuing an academic career in this field and be at the edge of the research. But how do you get started? How can you balance teaching with research? How do you secure funding and build a successful academic career? In this expert talk, we are going to answer all these questions. So we are honored to have Jack Silberman in our stage. So Jack Silberman is a robotics professor at UC San Diego in the United States. And he recently also led a super interesting research project on autonomous vehicles. And he's going to tell us about all those subjects. So let's welcome with a round of applause to Jack. Hello, Jack. How are you doing?
Doing good, Ricardo. Olá, ¿cómo estás?
Muy bien. Muy bien. So happy to have you here again so we can talk and we can share experiences so that the audience can learn and identify their path careers.
I hope I can help, and thanks to stick around until late in Europe time.
Oh, yes, and still what is remaining. I mean, still the conference has still some hours to go ahead. And then I wanted to start asking you about what is your role at the University of California, San Diego, and what does it entails?
Okay, so I'm what's called a lecturer, so I work in the industry, but I also teach, even though for the number of hours that I teach, it feels like a full-time professor, but it's a position that's called a lecturer. It's also known as a teaching professor. Is a chance to give hands-on experience to students from someone that work in the industry. So I guess that's a primary the summary for that. So I have a couple classes that I teach here. One of them is Introduction to Autonomous Vehicles. The other one is Introduction to Robotics Perception Navigation. Then I have one more class that's Internet of Things for the physical world. And I do many capstones that basically before students graduate, they have to participate on a final project. So I do that with electrical computer engineering, mechanical space engineering, and data science.
So you are combining also projects in your research, in your teaching.
Definitely. So that's what interested me to enable the students to get ready to do best as I can for the next phase in life. That's either graduate school or go to the industry.
Yes,
and moreover, during my research, I do autonomous car racing, and then underwater robotics, above water robotics, and then some air and combination between robots.
Awesome experience. And how are you able to combine your teaching, your lectures at the university with your current job as an engineer?
Yeah, so number one, I can't be teaching any medical device or biotechnology related classes just to prevent any conflict of interest. I work on a big pharma, used to work on a big wearable sensor company, and before that, biotech. So usually when I'm teaching, I do not get to teach biotech and medical device classes. So that I keep very separate, so that's easy. Then you start early, go back late, relatively speaking, and don't think if you're going to be able to do it, just do it.
Yeah, but I mean about the load of work, because I know that in your case, so you are basing your teachings in project, and then projects, they may or may not work, and then it requires a lot of hours to put in there. So how can you manage the load?
Good question. So a typical day may start at 5 a.m. local time. If I have some meetings on the East Coast, right, it's 3 hours difference between California and New York, for example. And the headquarters of the company that I work for, it's in the Eastern time. Or if I have a meeting in Latin America, that let's say someone in Brazil, for example, that will be 4 to 6 hours different, then you get to start early. Then maybe you're going to end my work at 5 p.m. I start teaching at 5:30. At 8:30, about to finish my class. Then I have the office hours or research meetings until 9:30. And then I go home and I sleep really, really well.
Just sleep very, very well. Yeah. And then tell us, so the people can get inspired about what sparked your interest in robotics and academia, specifically the part of academia.
Yeah, it's primarily to help others. So like since my undergrad, I was teaching high school, and then I was in the graduate school, I was teaching undergrad, just primarily, it's almost like coaching. I don't feel myself as being a professor. Yes, I teach, but I primarily enable the students how to learn, how to solve problems. I don't know about the answers. We go figure out the answers together. So pretty soon they know that, hey, this person has a PhD in robotics from Carnegie Mellon, and he doesn't know the answer. So it's okay with me to not know the answer and trying to find that answer together. So primarily knowing that you're helping people, knowing that these folks that you have a chance to maybe tune a little bit their life and ask them to help two other people, and then they help two other people. So that's what motivates me. I have a lot of fun. So students usually going to land at their own startup company, at a robotics company in San Diego, not necessarily just autonomous car, but in defense industry. I just have a TA that he got a job at SpaceX, so he's really, really excited. A lot of students going for the med tech, medical device, because San Diego is a hub for medicine and things related to that. So just like I have fun. It's almost sometimes I feel guilty to get a paycheck to teach.
Yes, I completely agree. But then which kind of skills do you need in order to follow a path like yours? So what did you study? What it was the skills that you study in order to reach the position that you have now?
Yeah, it's funny. So my career started by I went to a technical high school. So right there, when I was a teenager, I was already doing PCB design, and I was programming microcontrollers at that time. So it was natural for me. In fact, when I get to my undergrad, I was really bored the first 2 years because I was back just to do math and physics. Don't take me wrong, we have to do that, right? To be able to get to the next level. But I was really surprised that my friends, after the third year, didn't know how to read the resistor, never decided to design a PCB in their life. So I have to tune that. So after I finished, actually, this high school just got a robotics lab, and they asked me if I want to come and put it together. I said, yeah, I'll do that. And then when I finished that, they sent me to England to do some postgraduate work. Then I started to know how much I did not know. And then I decided to pursue my master in mechanical engineering because I have the electrical engineering. I want to work in robotics. I have to understand some of the mechanical aspect of the machine more than I knew. And then after I finished that, when I figured out that I could make money to go to school, I said, hey, why not then pursue a PhD? And then those things was coming natural, right? So I never thought that I was making a sacrifice to study. It was hard, don't take me wrong, really, really, really long days, but you get so many people with the same interests, the same, most important, same energy. You get to school and then you just feel good about it. Then you have to make a decision, right? You finish, for example, PhD. And in some companies, they think that a PhD is 1 degree too many because you're going to be too specialized. You have to make sure you don't really get into that narrow aspect of it unless you want to go to academia, right? And then you may find that get a job in the industry unless they are a research institution that you may not need a PhD. But a PhD will give a chance to be a PI, that's the principal investigator, raise your own money, and continue to have promotions on the company, right? For academia, for sure, you're going to need a PhD because for good or for bad, you need the degrees to be able to teach on a reputable university. And then definitely to have your own lab, you're going to need a PhD. And then to write grants, to get funding, you're going to need a PhD. So you have to find your tune, right? So I was fortunate enough, and then I worked hard enough to be able to then work in academia and go back, to the industry, and then go back and be able to teach when I get some seniority on my companies that I work for, and then went back to teach in a good school like UCSD. So I have been teaching for about 9 years or so, together with work in the industry, yeah.
And then, so what you are suggesting is that if you want to have a career at the university, then the PhD is kind of a must, right?
At least in the United States, at least in all the schools that you're ready to, yes, you should go for PhD. And don't take me wrong, it's like you're not going to have to pay to get your PhDs, right? There are many opportunities. In fact, the lab that you're going to apply or the school going to apply most likely has the fund for you for the 4 years. And then you're going to be writing then proposals for the people that come after you. So it's basically going to make money to study. Not a bad deal for me.
Okay, excellent. And what I have seen from what you have mentioned is the same theme that we have been hearing along the whole conference so far is this combination that you mentioned about learning about software and also about hardware, both things. Like it's important, right? If you want to be also even working at academia.
Yeah, so I don't think you're going to be a strong candidate anymore from the industry, definitely, that if you just have one area specialization and you don't cross into software, for example, right? Because you're going to be working, for example, if an electrical engineer, you're going to be working with mechanical engineer, you should at least share the same language. And then you're going to be doing some coding. So you better have your hands in doing some coding. And then for those people listen that you don't have the tech skills yet, just go do it, right? Nobody going to tell you don't do it. And then same thing for the computer scientists, get your hands a little bit dirty on the hardware aspect of it so that you sell your skills, right? Instead of being one, now you're a little bit more that people know that, yeah, he or she doesn't necessarily have a perfect fit for this position, but could be coachable. And then the academia, you will be interacting with other researchers, right? You can just be one person and do the whole thing. So you're going to be interacting with other researchers. So you should be able to communicate. And then students, they're so diverse these days, right? Maybe just my way of thinking, but I haven't seen in a long, long time someone that just specialized, for example, in fluidics. And they wouldn't know about simulation. They wouldn't know about some of the AI tools that help people solve problems they haven't solved before, right? People become really broad these days. It doesn't mean that you're going to have to know all. You just have to be enough to work with other people.
Awesome. Then you convince me. Okay, so let's see that I want to work at academia at the university. So which positions or academic roles can we apply for? You mentioned that you are a lecturer, right? And you explain.
Right.
And you explain which is like an external expert that comes at sometimes to the university and then deliver some classes, and that's it.
Right. Yeah, there'll be different positions. Number one, if you're going to be teaching, most likely, right, you're going to require a PhD. If you're going to do some introductory class on what you call the United States, a school that's not a 4-year school, it's called community college, right? You may be able to teach with a master's degree, maybe with a bachelor's. And I'm not here to defend one way or the other, right? But you're definitely going to need an advanced degree somehow. Then there is different ways to get to university. If you want to do really just the research, you don't want to teach, just apply for research position. If you want only to teach and not to be publishing papers all the time and worrying about bringing funds and then have a career that's a researcher, right, at the main lab, then you could be a teaching professor. And then you have the full-time professor that actually want to start their own lab and their own research center. And then that will be definitely research, advising PhD students, get some postdoc, writing lots and lots of proposals to bring on a fund, because eventually the school probably give you 1 year, 1+ year of fund, so you can start when they hire you, but then you have to bring your own. Other than that, you most likely will be asked to leave.
But these things that you are talking, so you are talking now about money, and and we need to clarify this, because for the audience, I'm pretty sure that many of them, they think, oh well, I don't know. So the academia, the universities, they are funded by the money that they get from the students. So then they hire the teachers, and so the teachers have a salary, and then they can do their job. But what you are explaining here is kind of a different picture. Can you clarify what is all those things about getting grants and
Sure.
and PhD students not paying for their job, for their position, for their doing the PhD?
Yeah. So let's just. I'm going to tell you in perspective of United States, right? I'm originally from Brazil. It's a different story because you may have the government grant. So in the United States, yes, there is a tuition for the university. For example, UC, that's part of the University of California. If you're a resident of California, you may be paying $22,000 a year. That's a public school. If you're out of state, maybe $70,000.
Wow.
If you're a PhD student, then maybe the cost of having you will be $100,000. And then a professor that will have a PhD student in the United States will have to commit to have at least 4 years. So that's right, that is $400,000, right?
Wow.
And if you have 2 students, and then soon you're already close to $1 million. And that will not going to come from the tuition from the students. You have to write your own grant, either for government agents, the typical National Science Foundation, Department of Transportation, Department of Energy, Department of Defense, of course, or you have a partnership with some companies that will sponsor your graduate student, and then they share the IP, the intellectual property, with the university. So yes, you have to bring your own funding. In schools in Europe is different, right? There may be the grant may come from the government and they're fully student. We compete on this autonomous car racing where some university from Germany, university from Italy come show up with 10 and 15 PhDs. They all fully funded from the government. And that's not the case in the United States.
Okay. So that's a difference between the United States and the Europe. We don't have much information about Asia, but maybe in the next conference next year, maybe we'll have some information and then we can share for that. So then let me ask you another question. So which career advice would you give to the audience that maybe want to pursue a research career at the university?
Yeah. So number one, the basic fastest would be pursue your PhD, right? Without a PhD, you're going to be really, really hard to get a research position, just really a plain research position. I mean, there is all rules has exception, right? It could be an exceptional programmer, and then you prove, and someone hear about you, and then they're going to go open the position in the lab, and you can join. But most likely the PhD will be the key for some of this. If you want to be in academia for teaching, the PhD is most likely a requirement. A postdoc that after you finish your PhD, you spend some time in the lab, in a famous lab, a reputable lab, that bring you some of the background information that you're going to apply later on for a teaching position. Right? Don't take me wrong when I talk about grants. Like, if just take a look, there are many students that they get the PhD program and they don't pay it, right? Someone wrote a grant for them. So there are quite a bit of funding out there. That means the research group that you are, your advisor, the lab that you are, wrote that proposal in advance so that when you get to it, you have your fund. And then you're going to be helping write funds for the next students come after you. So definitely graduate school, right? And then a PhD, and most likely a postdoc if you want to go for teaching. If you want to work as a researcher, you may not need a postdoc. You just go apply for those positions that are going to be available in many research institutions, right? And you may not need to be in an academia anyway, right? You may work for the government you may apply for a company. And then within that company, then later on see if they're going to sponsor your graduate degree.
Okay. Okay, I think that we can have kind of a map of the situation in case that you want to be a teacher or a researcher. Now, okay, then let's change to another topic about teaching robotics, because you are teaching. Actually, then how can you explain how you design and develop your robotics courses?
Sure. So in my case, I mentioned that I'm a lecturer. So because I have dozens of years of experience in the industry, so I was looking for the skills that students wouldn't need to be able to apply for a position in the industry, to be able to get a postdoc in a lab. And then every 1 or 2 quarters will go by quarter at the industry system. So I adapt to my curriculum. So I was looking for, if I'm sitting on that classroom, what it'll be like to learn, right? For example, deep learning. And then how do I do then an acceleration of the deep learning? What's the difference between a traditional programming robotics and deep learning or imitation learning? And then what is out there? What is open source? What has to be in terms of computer power to be able to run there? What kind of best embedded systems? So I develop a curriculum where the students may not know how to program, but then you do a crash course in Python. For the students who want to do real-time programming, they're going to do, for example, C, C++, and then how they combine a mechanical engineer and an electrical engineer to work together to build a robot. And in my class in particular, I flip the classroom. I show the results first. I show how they work to spark the students to be able to, oh, I really want to know how to do that, versus spending maybe 6 weeks and wait 8 weeks on the theory, and then have the 2 to 4 weeks of the class to do hands-on. And then you may lose some students on that time that you have been teaching all the theory. So I always flip back and forth, show the end results, get back to how to get to it, then introduce the new concept, get back to it, and then a lot of hacking, right? You may not know the answer. There's no way you can get a book these days, right? Things are changing so fast. Then, for example, the tools that you have in your company, right? I wish I had invented that. It's fantastic, right? So I don't have to take care of teaching ROS. Just the very first day, everybody have to get their own license, just like your ebook, right?
Exactly.
And then they start to build the robot. They use a simulation, and then the robot is built, and then they do the planning, and then that's another 2 other weeks, and then they already learn ROS. Now I have to do this with ROS applied to that to robot, right? So it's just fit on the flow. And every 6 months or so, get the new piece of hardware that you can raise the money to buy, and update all the robot, adjust the curriculum for things that they can actually get jobs. And that's why the lab that I work with, that I'm the PI, have an awesome record of putting people in the industry, right? And then going to graduate school.
Oh, awesome! That's a very big concern about for the students that are studying that, because maybe they will reach the conclusions of, for what I'm studying this, and what is my future after I leave the academia. So that is awesome, because they leave your classes with the practical knowledge that they can apply at the jobs.
Yeah, I get emails like, I may should compile this in a book somewhere, how I changed the life, the grit aspect of it, don't give up, don't get in the first week and get discouraged, because some of the mechanical engineers may not have experience of coding, and then they are ready to go drop the class, and I make sure that they stick around, that in 2 or 3 weeks, they're going to feel more comfortable. In 4 weeks, they can communicate, they can contribute, right? And then I get lots of feedback in terms of how the class by itself touched their life. Like I have usually 150 students on the waiting list. It breaks my heart. I'd like to have everybody in the lab, but we won't be able to do it, right? I just like to spend from 30 students to 6 students in the lab, and it's pretty busy. Right, so the average is about 120, 130 that go on the waiting list, because we can just not get everybody in the lab at the same time, right? So hopefully they'll be able to take the class before just the new year.
Yes, and then also, so you are talking about, I mean, your classes are very, very successful. I have visited you, and you show me, and I have seen all the things that you are engaging your students, and one of the things that you're engaging, apart from those practices, are the competitions, right? So what can
Right,
you tell
that's
us about
true.
the competitions that your students are participating?
And I just love it. And that comes from my graduate school. We would
Yeah.
put a robot in the field, and then we know that you're going to have, for example, this military helicopter. They're going to take a robot to the top of a volcano. And if you're not
Wow.
there, they're going to take off, right? You're going to lose that ride. You have this military airplane. They're going to take you to Antarctica. And if your robot's not there, forget it, right? And you
Yeah.
lose the whole aspect of your project, right? So in this case, the closest thing I can do is to have a competition. There is a deadline. Now you know you're going to have to go race in another university by that date. So everybody has to make sure that we know what is the deadline. It's a real deadline, just not a suggested time when things have to be done. So I love the robotics competition. We race from 1/10 scale, 1/5 scale, autonomous go-kart, all the way to an autonomous IndyCar.
Wait. You need to explain this because I think it's very, the process that you are following with the students is awesome. I think it's very interesting. So first of all, what is the competition about?
Yeah, so depending on the competition, right? For example, on a 1/10 scale, think about an RC car, but a good grade RC car. And then you're going to have to solve some challenge. For example, it could be just 5 laps and who has the faster time. It could be that has, like, say, a stop sign or a deviation, and you have to solve that problem, right? I do that on my classroom before you go to the competition. And then for the students that want to join the racing team, then later on they come and they want to join the autonomous go-kart. I have one on the background. You can see the go-kart there. It's basically a fully autonomous go-kart. And then the student have to have experience on the smaller robot first for obvious reasons, right? Number one, it is dangerous. It can hit and hurt somebody. Number two, is much more expensive, right? You go from $1,000 now to $10,000 to $20,000 more expensive. And out of that, the students that are interested and show the grit, right? Not necessarily they're the best programmers, so the grit that they won't give up, then they get invited to participate on our Indy Autonomous Challenge team that basically race Indy racing cars. So you probably saw those on TV. There are probably 9 of those cars now in the world. And then we race during the CS, that's the Consumer Electronic show. So I have students that basically participate with all the university as part of our team.
Awesome.
So incrementally, they get different skills and they learn things, and they go from 1/10 to 1/5 scale to then to the go-kart to then for a full-size racing car.
Yes, that's amazing, this process. And in each stage, they are learning the basics for that stage that allows them to go on the next one and do something and then start on the other one and keep building their skills, improving their skills in the different...
Yeah, and the risk is higher, right? Ricardo, just think about, you have a $1.3 million race car. We had an accident last year, the year before. I mean, if you drive a Honda, right, and I tell you, hey, they would $30,000 to fix, you say, okay, it's a total loss.
Yes.
When our race car was $30,000 to fix the front axle, that's all carbon fiber, right? And then it's way much more expensive, right? The computer is faster, the sensor faster, but it doesn't matter if there will be a spin out just because you don't have the dynamic of the car correctly, right? You was pushing the envelope, then you're going to spin out. And then if you hit the inside of the track, then it will be a very expensive proposition, right?
Yes.
So it's just not the skills, but the risk that go along with that, the fault tolerance, what we can do to manage the risk on the different level of robotics.
Okay.
You may think, okay, the camera is a camera, but now you're talking about a camera that refresh faster, right? They have the high resolution, or you have the high resolution, you have the faster computer. You're going to need GPU acceleration. Maybe you're going to need some TPU acceleration, right? That you just accelerated the tensor itself. And all these things keep adding, and then it becomes very expensive really quick.
Yeah, a network that can support the frequency at which you have to send the data. Maybe you need higher speed network around the car also. So many devices, higher...
Yeah, I mean, the idea you don't send anything out, right? So the car is self-contained. And then after do some troubleshooting, then all the information stay there. We just get some telemetry back because there's no way you'll be able to send the imaging, the LiDARs on a high refresh rate out, right? So it's not the idea, but the robot will be
I
so,
meant,
yes,
I meant that. I mean that the local network. That it's it's a special local network, cabled local network.
That's true.
Yes,
That's true. That's true. One gigabit, we're not going to cut it anymore, right? We think about each camera may have a 1 gigabit link, then you're going to have either a 10 or 40 that get to the main computer to be able to process the data. If you process the data on the main computer, right? Some of the smart camera, you start to process the information on the camera itself and bring just a high level information, depending on your approach.
Awesome. But then I'm a little bit confused. So
Okay.
this about the difference then between the project-based approach that you are doing and the competition-based. Is that the same thing, or are those different things in your teaching approach?
So they are complementary, right? So I do a project based on the class just because of work in the industry. I know what the skills that the students need to be able to get a job in the industry. I know what's the graduate school that I'm targeting, like hands-on graduate programs that they're going to need people that has this kind of skills that do field robotics, right? My specialty is not things inside the lab, it's things outside the lab. So I look for the programs that they do field robotics, and I can recommend the students going there. So then, therefore, you have to have a project, right? At the beginning, middle, at the end. And then nothing better than, hey, if you already have a project, why not using this project just finished to go compete? So you then pick maybe out of the 15 teams, you pick 4 teams that then you recombine the students that can travel, right? That you have the money for them to travel, and then they go and compete. That's part of, like, in terms of the research with the project, right? There are some other aspects that you may just have a grant, and then you do the research, and then you give them back to the company that sponsors students, right? They hold some of the intellectual property, and the university holds some of the intellectual property pre-already arranged before the research start, and then the company sponsors the entire student and the parts and the project.
And now that you mentioned about the intellectual property that the university and the company they share, so have you had any situation in which there are some researchers there at the university, and then they are working on a project, and then it looks awesome, so they decide to create a company, a startup, in order to sell this product or this idea outside? So is that possible also? Is one possibility in the United States?
Yes, all the time, right? Like a university, like the UC system has incubators where you take a class in terms of entrepreneurship, you go to that class and or workshop that they tell you how you're going to develop your minimal viable product. What is the minimal infrastructure they're going to need for your company? Where are you going to host? Maybe the university is going to host you for a little bit of time, and he give you access to the infrastructure. And in return, the university may own some of the IP. And sometimes they don't. They just really to generate the, new companies coming out of the university, right? And then you can go list them and say, hey, that's X number of companies we start. So depend of how this is being pre-arranged. Now, what I was mentioning is a little bit different, right? Industry is sponsored that PhD students, and now it will be hard for that PhD student to start their own company if there is a conflict of interest with that company that sponsored that work. For this reason, why I sponsor your work, I have some IP. Just make sure that whatever company you're starting does not conflict with who sponsor your research.
Okay.
I mean, trust me, there'll be lots of lawyers in the middle, and then you have to just be careful what you're doing, because sometimes people just leave you take off a little bit and go back and say, hey, I know that you're doing this.
What is about my thing?
They'll be complicated.
Yeah, I see. Okay, we are getting out of time, but I want to ask you at least one question more. Is about your opinion of large language models and how they are impacting in robotics education at the universities. In which sense?
It's funny you mentioned this because one of the things that I do in my class is this final project that they're going to have 4 to 5 weeks. And then for the very first time, someone who was using ChatGPT, not with the large language model, but they were showing an image and it was saying, find this object. In this case was a blue bench. And then drive to the blue bench. So the drive to the blue bench was developed by the student. To find that, we were just shipping the image and then get the result back. Where was that, where it found it? So that was super, super cool. Of course, it's not real time. It's not even near real time. It was just a proof of principle. And it was awesome, right? I mean, we'd say we didn't have to even train the model for the blue bench.
Okay, so then that what it means is that you are using this extensively as much as you can, but with the purpose of evolving the robotics technology, right?
Yeah, complementing. I mean, just to clarify, I'm not using that extensively because only one group that used, but that opened the whole world for us. We didn't even think about that. And this last quarter, someone this is, oh my God. We didn't think about this yet, right? How them send an image and then getting back, tell me what is in the image versus training your own model, right? You have YOLO, you have RoboFlow, just like someone did it for you already. So, okay, great. Let's try to use them. How fast it's going to be is a whole other conversation. Right?
Yes. And what do you think about using large language models in order to teach? So kind of replacing teachers in some way?
Don't know, Ricardo. I have mixed feelings, right? A lot of people say, hey, we should not allow people to use the tools and ChatGPT to develop some code. But if they're going to solve a problem faster, then how long going to be able to hold this? So I'm still trying to form my opinion, right? Okay. At this point, I'm going to be next week, I'm going to be teaching a high school class based on my college class, and I'm going to let them use whatever they want, just solve the problem. Let's see how quick they can solve the problem, right? Okay. Then now they become an architect versus the coding. Yeah. At the other end, if you want them to learn how to code, then if you're just using this, where is the limit, right? Is someone look on your shoulder, or there is a code, and then you go try to understand and improve. I don't have an opinion form yet. I just want to experiment, and then I'm open-minded. Right? Let's see what does it take us.
Okay. So let me tell you, yes, I'm impressed by this answer because very few people is able to say I have not formed my opinion yet on a hot topic like using large language models on education. So I think that's very, very cool, and it's something that we should imitate sometimes, not for that specific topic, but for some many other topics that we still don't know the answer or the
isn't today like time is money, right? How fast can you solve a problem, right? Now I have a whole other concerns in terms of this IP that was in there that you use, that they use permission. Is the students appending the fundamental? Well, since I'm teaching mostly the junior and the senior students, someone already taught all the fundamentals. Now it's time to get all that together, and then let's try to solve problems quicker. Don't take me wrong, it's a hot topic. There is a whole opinion one way or the other. I just want to experiment and then form my opinion.
Okay, so we'll be hearing or waiting to know your opinion whenever you have it. So please let us know. Then thank you very much, Jack Silberman, for your participation.
Take care, everybody.
Wait. Okay. You are not released yet.
All right, then.
This is time for the questions for Jack. And then, as you know, all the people there, all the audience, there is a question and answers tab on the chat. You can write your questions for Jack Silberman or both for the questions that are already there. And I will be asking those questions to Jack directly. And we have some questions already here, very quick. I had already prepared mine, but I think that theirs are more interesting, Jack. So it's a question from Andrea Perez that says, how challenging is finding funding for your research? Does the university support you? Is it generally funded by a project or by robotics branch? Like, like a company?
So first, let me put in perspective what's the funding look like, right? We're talking about $1,000, $5,000, $50,000, $500,000, $1 million, right? Depends on the research that you're doing, and then with depending on the money that you're looking for. For example, just by traveling for this competition, I just sent 15 students to Purdue University to race the autonomous go-kart, and I needed $29,000, right? In some labs, people say, are you crazy? This was just the travel cost, right? Think about hotel, air tickets, food, and that was $29,000. So what I did, I wrote some proposals from companies, and then between two companies, I was able to raise the money, right? Could I have used that to buy hardware and software? Yes. Would that replace the experience that the students had and then maybe touch 15 lives? And say no.
Yeah.
So
awesome.
how hard it is depends of the research line that you're doing, depends on networking, depends on the university, the reputation for university, definitely on the reputation. Usually the university has something that's called a CAP, Corporate Affiliate Program, where they're going to have a list of industries that you go after. And that's just industry, right? You have a whole other government institution that I mentioned before, right? National Science Foundation, Department of Transportation, Department of Defense, Department of Energy, NASA, and then that's different kind of funding, longer term versus a quick $30,000, right? I mean, if you ask for $30,000 for Department of Transportation, they probably even think you're not serious about, right? They're much higher grants, much longer process to get.
Awesome. Yes, completely agree on this about touching the student's life. It's true, and that can make the difference afterwards. Yeah.
And then everything that I'm saying is about the United States, right?
Yeah.
So I don't understand necessarily how the grant comes from Europe. I mentioned the self-funded student just because I know people that they can show up with 10 PhDs and 15 PhDs, all self-funded from Europe, right? Everything that I mentioned is regarding the United States, more specific with my experience at the University of California.
Okay. Then let me go for another question from Juan Pablo Alvidia that he says, how should you build a strong CV to get accepted into the best PhD?
Yeah, so good is not good enough. Show me the me different. If you just write, I'm very motivated, I'm hardworking, you and hundreds of people, hundreds and hundreds applying for that program, right? Find the me different. What you have done in your school that you're different from the other schools. Read about the research that someone is doing. Tell how it can help the researcher. Look, I read about it. I know that's the kind of work you do. I believe I can contribute because hardworking, motivated, everybody hardworking, motivated, right? Other than that, they will not be applying. What's the me different? That's what I can tell you.
Awesome. Yeah, and then everybody is hardworking and motivated until it's demonstrated the contrary. Also, so we cannot judge by this.
I mean, one more thing, Ricardo. Let me do this. Yeah. So find, I'm assuming in your school you're going to have this resources, right? Knock at the door of the researcher and say, I work for you free. Why is that? Because you build in a resume, right?
Yeah.
So then you have this first internship, then you have a second internship, and then you add all that on the resume versus someone that may have a GPA, right, your grade, higher than you, but they haven't taken the time to learn anything else besides the class. Go find those labs. Well, I don't have those labs in my school. What should I do? Find something in other schools. Find something in the industry, right? And then even if you're not making money, my first internship was free. My kids, they follow this, right? They all work for some very nice research institution, and in the beginning it was free. Just go there, knock the door. Hey, professor, I heard about the research. This is my career. Can I work for you? You free, right?
Awesome.
Volunteering.
Awesome. I completely support this also. Yes, awesome. Excellent. Then let me go to other questions here. Then let me see. Okay, so this is for international students, and then it's called Goit. It says, what advice can you give me to get a PhD in robotics in the USA? I am an international student,
right.
A master's degree in Barcelona. Thanks.
Yeah. Well, I was international student. most of the students that I see, they're international, so not a big deal. No difference in terms of, you're not going to have any disadvantage by being international, let's put it this way, right? It's a very, very international study board, especially for PhD. I believe at Carnegie Mellon was like a 60 to 40 in terms of foreign students to US American students. So there was no difference, right? Then what you have to do is find your path, right? You find what you want to do, what are the schools that that area that you want to study, what are the professors, what are the labs, and then you contact them to do best as you can, be respectful, right? Don't just waste their time in the sense of, quote, waste of time by saying, hey, I think you're really cool program. Really, that's it. That's all you know about my work, right? Do some homework. And then you have to be able to tell them how you'll be able to help on their program. For example, you could be a link for your Barcelona school. You may have a grant from the Spanish government to do what's called a sandwich, right? 2 years in Barcelona, 2 years in the United States, for example, any other place that you're going, or a full ride that you're fully funded. That helps. Money talks, right? And then you do that. Other than that, you look for the professors in your school that know somebody on another school, and then write them an email on the side before you even apply.
Excellent. I think that you got your answer. Great. Okay, let me ask, do we have time for another question? Yes? Okay, excellent. Okay, so here, okay, I don't know if I should ask you this one. It says, can you give us a roadmap for learning robotics? I don't know if that's too much.
No, easy. Like the first thing I did was I like to take things apart, right? Then,
what do you mean by taking things apart?
Well, we just like you're a kid, right? You start to get your toys apart, right? Put it back together, right? That doesn't cost anything because you just have the toys. So assuming I don't know your age group or things like that, right? But assume like robotics. There are so many free resources out there that you use in a simulator, because I don't know if you can afford something. I don't know if you have access to your hardware. I'm assuming it's generic, right? And you start to have some of the simulator. Maybe you're going to talk to the constructor, hey, do you have a scholarship? And maybe they have some scholarship. Maybe you offer something in return to have some time on their tools that they have. And I'm not trying to do a sales pitch here. I consider Ricardo a friend because I started to use his tools, right? Because I was asking to modify stuff to my class. And if I talk to a big company, they forget it. How many seats do you need? 60, forget it. I'm not going to talk to you, right? I'm assuming I'm one of the biggest consumer for Ricardo, but for all the purpose, this is an awesome tool, right? You don't have to buy any robot. And on the top of that, they enable you to use a physical robot without even having a real physical robot with you. So if you can afford, right, then you get some of the slices. If you can afford a physical robot, then there are so many kits out there, right? And then you start to hack it and find things that you start to build up by traditional programming. So I have to extract a line, and then I know color filtering. And soon you're going to find that color filtering you're going to break if you go outdoors, because the sun shines something on the yellow, now that yellow become green. Yeah. Well, then I'm going to use some machine learning algorithm to make more robust, or we're going to start to get out of the RGB color spectrum. Just experiment this with just on a Raspberry Pi, RGB camera, right? Jetson Nano from NVIDIA with GPU acceleration. So, I mean, there are many robotics kits, assuming you can afford. If you can't afford, jump into the simulators, right? ROS provides some simulator for you. And then there are many open source codes out there. Then get in a school, right, that enable you to do more stuff. Then you keep going, find a company that hire you.
Okay.
I hope it was not so much of a long answer, Ricardo.
No.
Trust me, I don't make any money to do construct, right? I'm a paying customer for this, guys.
Thank you very much, Jack. Thank you. And well, then I think that's all for today. We have to continue with other stuff. Then thank you so much, Jack, for coming here and sharing your knowledge. The people are loving your speech.
You're very welcome. I do know that I speak fast. I do have a cool Brazilian accent. So for those who want to know, I speak Portuguese, right? And then I do speak fast. And a couple of people asking me, how can you speak in another language so fast? I said, I don't know. I just go what comes to my mind. So go, to the best as you can. Grit, right? Don't give up. Don't give up. Don't give up. Learn how to get the nose, know how to go down and go up. Play some sport to get your mind going, right? And then keep going. And me, different, right? I'm very excited. I'm hardworking. You and the hundreds and hundreds of people applying for that position.
Yes. Okay. Yes. Thank you very much, Jack. See you.
Take care, Ricardo.
See you soon. Huh?
Gracias. Ciao,
See you soon.
everybody.
Bye-bye.
Yeah, see you soon. Bye, everybody. Bye.
Yes, thank you very much, Professor Silberman. Very interesting talk. And attendees, please take a moment to rate Professor Silberman on the box of the chat, because remember, we're getting closer and closer to picking the best speaker of this year's conference at the end of the conference. And wow, what a session. I mean, really, really interesting. I'm a little bit jealous of Professor Silberman's students, because, man, I wish I would have gone to his class.
Yes, I have seen with my own eyes, so that's
Wow, and I heard
true what he said.
I heard San Diego is a really nice place to be. So, very interesting. So, thank you very much. I hope you all enjoyed it as much as I did and are finding it insightful.
Absolutely. And now it's time to get some fresh air. So let's have a 10-minute coffee break.
Yeah, let's go, guys. But wait, this is not any ordinary break.
Ah, I knew it.
No.
I thought that there was a problem in the script, so I didn't.
Yeah, I was about to leave, huh? I want to remind the audience that you can still work on the limo challenge we have presented earlier in the day. So please remember that you can still submit your limo challenge.
Yeah, we are going to explain the limo challenge, but also talk about the Limo Pro robot. The Limo Pro robot is a ROS2 mobile robot platform that integrates NVIDIA Orin Nano alongside a LiDAR, an IMU, and a depth camera. Limo Pro has 4 modes of locomotion: differential drive, Ackerman, omnidirectional, and track-based. All these features make Limo the perfect robot for learning and teaching robotics with ROS. You can even add a robot arm and study autonomous mobile manipulators for a small price. During the Robotics Developers Day, you will find a big discount buying one right now on the button that appears at the bottom right of the screen. Buy one now and get a 20% discount.
Yes, and this is how for those who haven't heard, this is how the limo challenge works. First, I'm going to reshare a link correctly, I swear this time, of the project that you can open to complete the challenge. So let me do that right now. You should see that on the chat right about now. And once you click on that link, it will get you a copy of the project. And if you already have it, it will just open it up again. And you can press the run button, the green one on the top right. This will open the project, just like any of our other projects. And you will see the instructions of the challenge open automatically. So what you need to do is follow the instructions and solve the challenge anytime during the conference. That's great. The challenge is very easy. So move the limo robot it's not very, it's very simple. Move the limo robot from the start position to the goal position. You can see that in the picture there. Start position is where the simulation starts. The goal position is right on the other side. And then you have to take a picture of what's in front of that goal position. And you can use the simulation to test all this and develop. So once you have solved the project, make sure to send us an email with a link to your project to info@theconstruct.ai. Again, that is info@theconstruct.ai with the subject Limo Challenge. And out of these projects that we get sent, we'll randomly pick one. to test, well, as many as we can, we'll start with one, to test it on the real limo here, on the real environment we have. And if the code works, you win the robot. So that's how it works.
Wow.
Wait a
So-
second. Let me clarify that we are only getting the first winner. Okay, so the first winner is the one that's going to get the limo. So we are not going to be testing all the.
No, yes, I just meant that if for whatever reason we get a project that doesn't work,
Yes.
or whatever, we'll just go to the next one, right? So, and then the first one that works, it's a random process, so it's like a lottery ticket of the submitted projects.
So yeah, later we will see who is the lucky one. So now take the time to refresh yourself and enjoy the robot contest, and we will see you in 10 minutes.
Let the robot games begin.
Welcome back, everyone. We hope you had enjoyed this short break. It's really short. We hope you enjoyed the robot contest. Remember that you can keep working on the project if you haven't solved. Just send us a link to our project once it's done.
So now, guys, it's time to get ready for our next session, which will be a hands-on learning session. So this presentation will be interactive. So you need to open the robot project that comes along with the speaker. So all you need to do is click on the open ROS check button right next to the speaker. And sorry, so you have to click that and it will open. Don't worry if it loads for a little while, just wait for a few seconds. And while it's opening up, Jazzy, I think we should look up who is the winner of the social media.
Yeah, since we're keeping an eye on the hashtag, so let's see.
Yes, remember to share your posts under the hashtag RoboticsDevDay. So let's take a look at maybe...
This one is new, right? The previous from this guy, we also saw it on the previous, and this one with the cat.
We saw the cat,
Oh.
very nice. We saw Angel, who won one. We saw the notes one as well. Robert, very nice one.
Robert, awesome.
And we also saw this one. Make sure you post new stuff, guys. This one's new.
It was new, and this one also new.
I don't think so. I think this one's older, as well as this one. So let's do this. I mean, I like the guy with holding up the mug or that new one. So any of those two for me.
Yeah. What do you think, Jazzy?
Well, for me, I vote for the cat one.
Nice, nice.
Okay,
So I guess the deciding vote will be Ricardo here.
Come on,
Also-
this guy one.
There you
has
go.
Coffee.
The
This
guy
because he has coffee.
shows his face.
I'm sorry, coffee wins.
Yes, yes.
Coffee wins.
So congratulations. I couldn't see your name, my man, but we'll get in contact for the shipping details.
Yes, so we are going to contact you. So what do we have next?
So now we move on to the Pyroboplan session.
Yes, because one of the basic skills of robots is the control of a skillful robot, is to control a robotic arm. Robotic arms are everywhere in industry, so understanding how they work, it's like a basic skill that you must possess if you want to work in robotics. So in our next speaker is Sebastian Castro, and he is a robotics engineer and educator. He has created recently a Python library to better understand how robot arm motion planning works. Today, Sebastian will guide us through robot arm motion planning with Pyroboplan. Welcome to the conference, Sebastian.
Hello, Ricardo, and hello, everyone. Thank you for the opportunity to speak here.
Yes.
It's a pleasure.
Hello, nice to see you again. And then, do you have your presentation ready? Your project, your project?
Ready. So I should be sharing my screen now.
We can see it. So the audience is all yours.
Perfect. All right. For those of you in Europe and east of that, I commend you for still being awake. I will try to make this as exciting as possible. I'll also try to hear the chat. It seems I'm too quiet from what I'm seeing. So let me see if I can modify my input volume. Am I a little bit louder yet? Is that any better? Hopefully that's okay.
Yes, a bit better.
All right, wonderful. Okay, so while the ROS check loads, you're going to see a bunch of things running here on the terminal on the right. So hopefully your installation is complete by the time we're done with the introduction. So I'll tell you a little bit about myself and about kind of what this presentation is about. So as Ricardo said, I'm going to be talking through this Python-based educational tool I made called Pyroboplan, which we'll spend a lot of time with. And I'll tell you why I made that and where it fits into the ROS ecosystem. Because one thing you're going to need to know from this talk is that we're going to be using 0 ROS. So how does this come together? So let's get to that. So this is a little bit about me, right? I'm currently working at the AI Institute, which is a research offshoot that spun up from former Boston Dynamics founders. But in my career, since I started working in 2011, I've been kind of oscillating between the areas of education and then actually, working in different kinds of companies, some larger, some smaller, some more focused on software, some more focused on product. So one thing that's always on the back of my mind is that making robots do something that we can easily think about ourselves is actually really hard to implement. And of course, there's been a lot of tools that have come out to make this easier, not the least of which is ROS. But I still think that overall, I think a lot of us as roboticists want to solve problems, and sometimes it can be a little tough to kind of be stuck in the software land just to like learn things or iterate on things, come up with prototypes. So that's really been my motivation. There's a lot of great ROS frameworks for doing motion planning with robot arms. You might have heard of tools like MoveIt or Tesseract, or even equivalent frameworks in other areas like Nav2, for example. These are all very capable tools. They're very extensible. They let you create plugins for customizing. They connect very much with other pieces in the ROS ecosystem. So these tools are very good for getting something working and talking to a robot. But even if you've seen the talks, that we've gone through today, we haven't needed to worry very much about how the actual algorithms are implemented. And I think that's a good thing, right? I think it's great that with all these ROS tools, you can basically, grab your EKF package and have something working with only configuration files. That's like a big power of ROS. But sometimes, especially as newcomers, either because you're more junior or because you're learning a new area, sometimes it does pay off to have tools that maybe are a little less targeted to that and something that facilitates your own educational experience. So that's where Pyroboplan comes in. This is kind of my trying to figure out how these motion planning libraries work for manipulators and giving people a hopefully easy to use platform for that. So hopefully I've spoken enough that people's installations are complete. I am seeing the chat. So if people want to say whether they're still installing or they're complete, I'll be looking at the chat log as well. But as it says here in the notebook, when the installation is complete, you'll be able to see this installation complete on the terminal on the right, and now we can actually start opening stuff. So let's just open one quick example to check that we've kind of loaded things up correctly. One thing that this requires is that because of the visualizer that we use, we need to use Google Chrome, and there's some interesting artifacts in making that work here. So if you scroll down to here, open up a new tab and do sudo Google Chrome no sandbox. That will get Chrome to spin up in these ROSjects. And once you've run this command, you'll see that the graphical tools will appear, and you can kind of blow through all these prompts. You don't have to sign in. We recommend not doing that. But eventually you'll get a Chrome window that we can use to actually look at our visualization. So hopefully you've gotten that set up. As far as running our examples, I'm actually going to go back to the terminal here, and what we'll do is we're going to change folders to the Pyroboplan/examples folder. And then here you'll see that we have a bunch of Python examples you can run. These are the ones that we're going to use for the duration of this material. You can also go to your IDE And under Pyroboplan examples, you also have access to all of these right here. Okay. So, when we run these examples, we'll get to kind of look at the code a little bit and see how this stuff works. So let's talk first about how we can model our robot arms. So the first example we're going to run here is this intro Pinocchio manual file. This tool was made by reusing existing libraries that already let you model robots. And if you haven't heard of it, there's a really great library called Pinocchio that basically gives you the ability to create these, rigid body articulated robots, do things like, kinematics and dynamics. And Pinocchio is actually available in the ROS ecosystem, so you can, depend on Pinocchio as a package and then use it both in C++ and Python. So I'm just going to share with you a few basics here, and we'll explore how this works. So we're going to run this intro Pinocchio manual example. Again, we're going to navigate to our examples folder. We're going to run this, and you'll see that as we run this file, at the very beginning, it'll tell you that you can open the visualizer by going to a particular website. And this website will pretty much stay constant for the duration of the presentation. So if I type in 127.0.0.1/static, oops, I missed the 7000. Remember the slash at the end, otherwise you don't get the page. And I must have forgotten something here because the example is still not loaded. Let me go again. Sometimes it's also that the example actually finished running by the time I spoke. So sometimes you can also bring it up and refresh. Okay, so if things show up correctly, you should see some visualization like this. Let me know if you guys are able or not able to see it. But this is just going to pick a random position for your robot and display you a couple of things, right? You'll see in this whole visualizer, the reason I'm bringing up this basic example is twofold. One, you see that our robots, the very basic way of modeling robots is that we can create these little assemblies that have rigid bodies like boxes or cylinders or spheres and connect them together with links and joints. And as you expand this mesh cat thing on the right, you can actually look at the names of the individual bodies like link 0, link 1, and you can enable and disable them. So you actually have full access to seeing what links are on your robot and so on. Same thing for the joint frames, right? So joint number 2 is at a particular place on the arm, and then so on. So this is kind of the basic things that Pinocchio lets you do. You see if we open up our IDE, these models are all made programmatically, so you can manually do things like adding links and joints and defining transformations and shapes, etc. Okay, but very often we don't define robots programmatically like this. If any of you have been working in ROS for more than maybe half a day, you'll know that there's other formats like URDF models, right? And indeed, most motion planning libraries do ingest that. So there's another example here called Intro Pinocchio UR5 Sim that you can run. And you see this is actually going to load directly load a URDF file from one of the packages that we've included that's also contained in this folder. You see it's under here in the UR description. So let's run this one instead. This one is called Intro Pinocchio UR5 Sim. And if we go back to our browser, you'll see if I refresh, I now have an actual universal robot that's going to be moving around, and there's a lot of things displaying on the screen. It's printing frantically, just to kind of show you what's going on, right? One key thing here is once you load these models, you'll notice that there's now, if you expand this, there's both a collisions and a visuals model, right? So usually for these manipulators, you have a model of your visuals meshes that has the full quality meshes. And then you also have collision meshes, if I uncheck and check the other one, which are usually more simplified meshes that are easier for collision checking. And so then you also see these green lines that show you the distances between non-colliding parts. And there's also actually sometimes the arm will cross itself, and you'll see some red displays showing the parts that are in collision. So what I'm getting to is that when you're working with these models, you're usually loading from these URDF files, whether it's in these libraries or things like Gazebo or Move It, where you have this robot, where you've defined, things like links with visual geometries and collision geometries, and the tool can kind of ingest that as well. So that's like my as quick as possible crash course to robot modeling. Again, if anyone has questions, I will still be monitoring the chat as I go, but we can also save some for the end. So this is basic modeling, right? Like we have a robot that we can do basic kinematics and dynamics and collision checking, but at the end of the day, we're here for motion planning. So let's dig into some of that stuff. I'm gonna stop the script. So and let's look through the notebook. Okay, so those are some of the basics of modeling. I'm actually gonna skip some of these other ones, but you have the ROS checked available. Just something that showed you that you can do collision checking along a path. But let's talk more about motion planning, right? Critically, when you're talking about motion planning, there's lots of different ways to mix and match it. But I recently drew this diagram that kind of shows the classical steps of how you go from getting your robot to move from one point to the other, right? When you're commanding your robot, you're either telling it to go to a particular joint position, or you're giving it a pose. So this is like an XYZ and rotation of like some part on the robot, like the gripper. Sometimes you need to convert that to joint positions by doing what's called inverse kinematics. So we'll look at that very quickly. And then at the end, you're trying to move your robot to a particular location, a particular joint configuration. The thing is, you usually can't just move in a straight line because you might hit things. So you might, collide with the robot's links themselves. You might collide with the environment. So path planning needs to account, what is a feasible way to move to your goal without hitting things. But that only gives you a path. You then need to take into account limits on your robot, like if you have like velocity limits or acceleration limits, torque limits. So you now have to convert that path to something that the robot can actually execute as a function of time. And that's what trajectory generation is. And then once you have a trajectory, which is like basically the positions, velocities, so on of the joints over time, you can finally take you go to your robot controller and run things. And this is where things like ROS are very useful, like the ROS2 control package. So we're going to spend the rest of this talk just going over some of the examples for each of these components. Well, at least for the inverse kinematics, path planning, and trajectory. Because this is a simulation library, we don't really have much on the control side yet. So let's talk about that. So again, inverse kinematics this is a lot of math here, but bear with me. Inverse kinematics is the problem of saying that you want a particular part of your robot to move somewhere else, and you need to figure out what the joint angles are to achieve that. For some robots, it's very easy to do the math for that. For other robots, it's not. So there's lots of different algorithms that achieve this, and we're just going to go through one of them and just kind of show you how the tool lets you explore these things. So what I will do, under the examples, we're going to run the, as it shows on the notebook, we're going to run the Python script differential ik.py, which is actually the algorithm you see on the screen. And when you run this and open up your browser, you'll see now, hopefully this looks okay over the presentation, but basically you have your robot living in the world, and then somewhere there's going to be a coordinate frame for the target pose that it's trying to get to. I'm trying to find it. Oh yeah, it's over there. So you see, you basically have your robot solving over time, and it's trying to move one of the coordinate frames into the other one, and showing you on the script whether your robot solved it, or is it inside or outside joint limits, is it in collision, and you get a couple of retries. This is done completely randomly, so it'll pick a random pose. For you, you might have gotten a configuration like this. For others, it may take a few tries, and then the script just keeps running and tries a bunch of random poses to see how you can solve inverse kinematics from one point to the other. So going to the IDE, you can see that the way that these examples started working with motion planning is that you load a model, and then you have these relatively basic classes like, differential IK options, and you can just run them. You can, plot different things about them, display them on this visualizer, and so on. And when you want to go to these implementations, the actual library is the one that has the the actual code. I'm just going to open the code for one of these just to show you that the code has a lot of comments explaining the parameters, but also links you to resources for where the papers this was implemented from. It also gives you as you go on information about what are the mathematical steps that are happening. So hopefully this helps you learn or even quickly modify your algorithms in Python to see how motion planning works for you. So yeah, again, there's many ways for inverse kinematics. This is where I will also start plugging a little bit and saying that I've only implemented one IK algorithm so far, but the idea is for this tool to be fully open source. So if people want to try their own algorithms or variations, you can contribute to this library and share with all your robotics peers. Okay, so inverse kinematics is one thing. Again, this is just showing you the progress of this optimization to move to your target pose. Suppose you've already done your inverse kinematics, right? Next, we're going to get into the actual path planning, which I think is probably the one that we want to spend most time on. So one of the classical ways of doing motion planning, and this is actually one of the key features in MoveIt, is this notion of sampling-based motion planning. This is where if you're trying to move your arm from a start to a goal, you basically are, doing some kind of planning where you're trying to go from start to goal without hitting obstacles in this high-dimensional space of your joint angles. And there's really two main flavors of sampling-based motion planners. If any of you have heard of them, these are probabilistic roadmaps, or PRMs, and rapidly exploring random trees, or RRTs. And these have some slight differences. The big difference being they both kind of look the same. If I just scroll into this picture, they all sample a bunch of points until you get a collision-free path to go from point A to point B. That's a constant. But if you look at the probabilistic roadmaps on the left, are a lot more. They have a lot more points on the graph, but you can actually reuse them. So they're called multi-query planners. It means that you can actually generate this big graph and use it for like multiple motion plans. And then on the RRT side, these are less dense, but they have a finite lifetime. So when you plan an RRT, it only plans from start to finish, and then you throw away the planner. So I will go back and I'll show you some examples of this. We're going to start with a simple robot just to give you the contrast. So if you guys run there's an example called PRM2DOF.py. So this is going to run the probabilistic roadmaps for a 2-degree of freedom arm. And this one takes a little while to load, but I'm just going to refresh. And you see I have this arm that lives on a disk. And then you have these, you can actually turn on and turn off different things like the actual graph and the planned path. So you can say, oh, I see how this path looks like. I'm going to go from one point to the other. So I'm going to hit enter and animate the path. Robot's going to move without hitting that green circle. And then this is kind of like an addictive game. You just keep pressing enter and it's going to plan to you a new path to go to. And then it's going to plan over there. So you can feel free to play around that with your ROSject or install locally as you want. So this will just keep going, right? Again, the key thing is that you saw that the script took about 5 seconds to start, but the subsequent planning was really quick because you're just reusing that graph and just doing search. Let's do that in contrast with the other example, which is the our other sampling-based motion planner, which is the RRT, or rapidly exploring random trees. This one, again, I'm just going to refresh that. So this one, you see it generated this, it's a much more sparse tree, but you can see what's happening. And actually, in this case, planning timed out because it couldn't find a path from start to finish in the time allotted. So I think I'm getting unlucky with this one. Sometimes there's these little nooks that you can't really hit with the RRT. So you see it's trying. At some point, it might get a valid path. If not, then I might just restart to get a new random target goal, which I think I might do just. So maybe you are seeing some paths. Okay, so this one you see, this one didn't actually have to sample a bunch of nodes because RTs are interesting in that they can like bias you towards the goal. So you don't have to sample the entire workspace, you just kind of sample towards it. You see here, you're running through the path and it works great. And then you can keep planning. You see you get a new path. This one's really trivial, so it barely did any planning. So as you keep trying different ones, you might get more complicated trees. You might have noticed some things that with sampling, it's you get these like really weird paths that look very not optimal, and that's kind of the downside of doing sampling-based planning, right? But there are tricks that we can use to get around that. But I'm gonna, let's try those out. So if you go to your IDE and you open up that RT2.dof example, I want you to look at these options. And there's actually a couple options we can use to make the plan quality look better. If you go in here and you change a couple of options, so I'm going to set bidirectional RT to true and RT star to true. These are some variations of the RT algorithm that are documented also in the implementation. These are going to do stuff that improves the quality of motion plans by doing two things. But I'm just going to rerun to show you what that is. So firstly, the notion of bidirectional trees means that you're now going to do planning with trees, two RTs. So one tree starts from the goal and goes backwards. The other tree goes from the start point and goes forwards, and they try to meet each other. And you see that that's where the pink and the blue trees kind of converge on each other. The second thing is this RT star. You notice now that the tree looks way less jagged because RT star actually, once you sample a tree, it tries to like rewire it and then tries to like create shortcuts in the plan. So you can get something that is less, wonky and moves around a lot. So these paths look better, but they still have the characteristics of, you're just at the end sampling a bunch of stuff. There's a lot you can play with these tools. The cool thing is that this doesn't just work for a 2 degree of freedom robot. If we instead run the we run the RT example for the Panda robot, which is a 7 degree of freedom robot, you can actually do exactly the same thing, but visualize it in a higher dimensional space with 3D obstacles. So now, you see here planning timed out again. For me, because I must have picked a bad pose. But maybe when we try a different random seed and refresh, you see that sometimes the RT does give you solutions. Again, you see this path is basically like a 3-dimensional sphere version of what we saw before, but it just looks like this hideous, like almost traversing a globe in a really awful way. But you can apply the same tricks as we just talked about, right? If we go to the same RT Panda example, I can also turn on the bells and whistles, like turning on the bidirectional or the RT star. I can rerun that, and hopefully now, if you try again, you get paths that look a little bit nicer. They still have some issues, but you can see this looks maybe closer to what you would expect your robot should do. Yeah. So hopefully you can play around with that. There's lots of other types of motion planning, so we're not going to stop there because there's a couple of things that we need to talk about still. So we have these paths, right? In all these animations, I'm just basically picking a constant velocity for the robot to follow the path in. But we know that that's not necessarily feasible because your robot might actually have limits associated with them. Like we talked about things like maximum velocities or maximum accelerations. So that's where you get into the area of trajectory generation. Trajectory generation is kind of, again, what you need to bridge between your path planners and your controllers. And there's a couple of different ways that most people do these. The two that have been more standard classically are these two that you see in the diagram. You have trapezoidal velocity trajectories and polynomial trajectories on the right. They both have their benefits. The trapezoidal velocities are very easy to implement because they basically follow a very rigid rule of like going as fast as possible, staying at the fastest speed, and then decelerating. but they leave a lot of optimality on the table. They're used a lot in industrial arms because they're very easy to do. Polynomial trajectories, on the other hand, have more smoothness properties. Like you see, for example, depending on like higher orders of the polynomials, you can have you can get away with like discontinuous accelerations or discontinuous jerk. But they also are a little bit. You need to figure out exactly what the boundary conditions are in both cases, really. So both the examples that you see here are doing a trajectory with two segments that is basically starting and stopping at 0 velocity, and that's how a lot of these work. We can actually run that. So if you look at the, we have an example here called trajectory generation.py. And when you run this example, you can configure it to either run a trapezoidal or a quintic. This is a, maybe I should write this. This is a 5th order polynomial trajectory. So you can choose whichever one you want. I'm just going to start with the trapezoidal trajectory, and I'm going to give it limits of maximum speeds and accelerations of these values, right? You can play with those if you want to see if you can make your arm go faster or slower. But let's run that. So this one is called trajectory generation. And then I'm just going to refresh the page. Well, actually, before refreshing the page, this now starts bringing you plots. And if you watched Thisas' talk, this is also the same matplotlib library that I'm using here to display the trajectories. So this gives you the joint motions for the joint trajectories for each of your joints, like panda joint 5, panda joint 4, etc. And you can validate whether you've met your min and max accelerations, for example. If I find my browser, again, I have to refresh Meshcat. This one will just show you that your trajectory just tries to go across 3 points. So you see you've got those 3 coordinate frames existing there. And when I hit enter to animate the path, it's going to start, accelerate, then decelerate at the middle point, and then accelerate again from the middle point towards the final point. The trapezoidal and the quintic look slightly different. You're not really going to be able to maybe tell very much over this presentation, but maybe certainly the plots look different, right? They don't have that trapezoidal velocity. They are now like 5th order smooth polynomials, so the acceleration is also smooth. And when you run this trajectory, it might actually end up looking very similar. Oh, I didn't refresh the page. I'm sorry. I'm going to have to run that again. Okay. So again, it just picks random points, but this might look the same because you're, again, starting and stopping at 0, but just the profile looks slightly different because it's not trapezoidal velocity. Okay. So there's there's 2 other things about trajectories that I want to talk about before concluding. I know it's a whirlwind tour, but I'm going to give you a lot of resources to do more. So 2 problems, right? Actually, when we ran, I'm going to run the RT example again because I want to show you something. When you do these RT plans, whenever you're doing any kind of segment in your path planner, it's actually a straight line in the joints of the robot. However, because the robot arm kinematics are not linear, a straight line in joint space actually is not a straight line in like the real world. It has no ROS dependencies. That's correct, Anderson. It's fully Python installable. Yeah. So what if you actually do want your robot to move in a straight line in the real world? Like if you're trying to do like a painting task or welding or something like that, you're going to need another set of techniques. And actually, there's a very common method that's called Cartesian space planning. I guess I flipped this backwards, but just scroll down to the Cartesian planning part of the script. One thing you can do is actually do all your trajectory planning in the Cartesian space. So in other words, the X, Y, Z translation and rotation. And then for each step in your trajectory, you basically solve inverse kinematics from one step to the other. So you actually get the modified joint trajectories that give you a straight line Cartesian path. And this is something really common to do in robotics. So I believe this is just called Cartesian path.py. You can run that. And if I refresh, you will again get this little window. This is actually, I have a really small story to share with you here. When I hit animate on this Cartesian trajectory, you see this like vertical line that's moving with time? I think that's really cool. This is actually some random person that I didn't know that just saw my repo and was like, hey, I really want the straight line. Submitted a PR, we got it in. So I really like seeing these kind of contributions. So yeah, you can see your robot is like tracking an actual set of straight lines. So that's fun. Yes, and I believe it was at the last MoveIt that some of the construct folks presented on their new Cartesian planning class as well. I know you guys had a smaller bite-sized section as well. Cool. So actually, the method that I just showed here is very similar to how MoveIt would do it, right? Where you try to solve inverse kinematics for lots of points along an actual straight line. Okay. So there's one more thing that I want to talk about in the next 5 minutes before wrapping up. And that is, in both of these trajectories, we noticed that there was one thing that was not ideal, which was, why did we, if we have two segments in your trajectory, why did we can set any speed we want, but how do we know it's a good speed? So there's been lots of techniques recently that do trajectory optimization, where you actually try to optimize the parameters of the trajectory so that you basically try and minimize the time it takes for your robot to safely track something. There's lots of methods to do this. What I'm doing here in this library is I'm using the tool called Drake from Professor Russ Tedrake's lab at MIT, if any of you are familiar with that. But you're actually able to take these trajectories and put them into an optimization problem, which I think is really cool. So you can run this trajectory optimization example. When you get these plots now, you see that all the trajectories basically are like maximizing their velocity as much as they can, and they're not stopping at zero. So you actually get trajectories that, even though they have, in this case, I think it's 7 segments, they're basically optimized to minimize time while meeting the velocity, the acceleration, and jerk limits of your arm. So if you run this, you've got this. Oh, did I hit enter? Yeah, you've got this path now that is way snappier than before. It like really accelerates at the center and then slows down only at the endpoints. And then it just keeps going. Last thing I will say is that there's also a way to combine these things. So there's one last example, which is called optimize RT path. So what if you could take a path from an RT, as we saw, it was not necessarily the most optimal path, and then you try to put it through a trajectory optimizer to get a full trajectory. So indeed, you can do that. You see you've got these like funky looking joint trajectories here. And if this wants to load, oh, somehow the address changed, so now it's 7001. But now if I do this, you see you've got your basically your RT path and your optimized path. They're shown side by side, but you can go into MeshCat and basically, turn off either the planned path or the optimized trajectory, and you can see how different they might look. Where the planned path has this like swirl, but maybe the optimized maybe looks the same, but it did optimize it to at least not have 0 velocities at the endpoints. And then you'll see your robot basically doing the whole following of this while hopefully avoiding collisions. This one looks like it's going to get close to collision. So yeah, I guess the big takeaway, because I know I have 3 minutes, is that there are a lot of features here for you to kind of play around with trajectory optimization, path planning, all the different flavors. It's fully done in Python, no ROS, so you can just import your model, try things out, and hopefully make contributions. I'm going to say one set of concluding remarks, though. At the end of the day, I do think you need this to run on a robot, right? And this tool is not going to do that. It's also written fully in Python, meaning that it's going to be very not performant compared to some of these tools like MoveIt, which are written in C++ for a good reason. You saw that like my RTs here were timing out after 10 seconds, which would be an offensively long time for MoveIt to do an RT. Like that should really take no more than a few seconds in these, or like even it shouldn't take more than like 1 second on these relatively easy problems. So I think the goal of this tool and tools like this is for you to kind of learn the basics so that when you go into these frameworks like Move It or Tesseract, you actually maybe know what you're looking for. You understand the role of the motion planning in the bigger scheme, where you have to then take this trajectory, send it over to a ROS2 controller, etc. So, you know, I think that there's room for all of these tools. It's just a matter of what your focus is at the moment. You know, are you prototyping? Are you trying to learn? Are you trying to introspect? Or do you actually want something to work on real hardware in real time? So definitely check that out. If you want to know more, I have the Pyroboplan repo is fully available. I see someone already linked it, which is great. And if you want the not abridged version of this presentation, I recently wrote a full blog post that is very, very long, but talks about this in lots of detail and links you to a ton of resources for learning both the mathematical foundations, the software tools that exist, and other common algorithms you might have. So definitely check that out. You have the ROS Checked available, you have Pyroboplan, you have my information if you want to talk to me. Thank you for making it through that. I finished on time, shockingly.
Excellent. Excellent. Sebastian. Yes, it looks like you were on the second there. Excellent. So now it's time for the audience to ask you questions, and for that we have the Q&A section tab on the chat, where you can put your questions to Sebastian or both, the ones that somebody else has put it there, and then I will be asking to him the questions. Okay, great, excellent. Yeah, okay, so excellent. So we have one from Thisas, one of the previous speakers, and has been one of the most voted here so far. Then it says, could I try to run this on a real robot, like, for example, ABB?
Yes, absolutely. So I mentioned this a couple of times during the talk, that I mentioned ROS2 control a lot, and ROS2 control, which is maintained by Dennis Stogel, which did one of the first talks here, among other folks. It really plays into the modularity of ROS. So what I would do if I had to use this tool and send it a motion plan to a robot, I would package up the resulting trajectories from this tool, I would put them into a ROS trajectory message, and I would send them to my favorite ROS2 controllers. Lots of different robots like Universal Robots, Kinova, etc. have ROS2 controllers already available. I'm not sure about ABB, but if it does, it makes that a lot easier.
Okay, yeah, so now I don't know that's ABB if it has drivers for ROS, but does it? Do you think? Yeah. Okay. And then the important point here is that the trajectories that are generated by the Pyroboplan, then they can be used and transformed into messages of ROS messages. I mean, that you can send to ROS to control.
Yeah, and I think someone was talking in the chat about the no ROS framework. I think that the way to design these tools is something like this, whether it's in Python or not, where you have this like tool that you don't need ROS for, but if you do want it, you could write these wrappers that can do the right data type conversions and put things into ROS nodes. So you get the best of both worlds, right? You have something easy for prototyping and something that can talk to your hardware.
Okay, excellent. Let's go for another question here. So Robert Cowher says, how does this type of path planning compare to reinforcement learning methods? Could you elaborate on the learning methods here, specifically how it picks the appropriate path from the various sample options? Can it tweak an existing best option, or is improvement just continuing or to random sample?
Oh, well, that's like, that question is basically a whole history of the history of motion planning, right? Because the first ever implementations of sampling motion planners were, the very stupid thing as you described, right? Which is just keep randomly sampling, maybe something better will come along. Then there have been variations on these planners that actually try to use some real information to try shortcut paths. And the thing about these methods is that, it's hard to get them to do something very optimal, but you know, because you're actually implementing these algorithms, you're checking collisions, you can guarantee that the paths will at least meet the requirements that you're validating against. With machine learning methods, they can do very impressive things, but you need to similarly find a way to validate them, right? There's been lots of ways to use RL to accelerate planning in lots of different ways. I recently saw some places that try to, use, I think it's a really good use. They try to use machine learning to do faster collision checking by using, basically having a learned model generate these like signed distance fields for collision. So you don't have to like do these expensive, polygon mesh collision pairs. You just like trust that your learning algorithm does stuff right. It comes with risks, right? So I think that the key behind the RL methods is that you need to validate them anyway. Sometimes they'll do good things, sometimes they won't. I'm a big believer in, if you have the compute to like try to compose them in different clever ways, or even try to run them in parallel. So like, if the learning algorithm doesn't give you anything good, you can fall back on a more old school planner that at least does the job. I think ultimately in robotics, the biggest goal is to make sure the robot doesn't get stuck and can keep moving along, even if it's not quite as optimal as you want it to be.
Yes, to get stuck into a position from where it cannot recover.
Exactly.
Okay, then another question from Got It. Got it. Yes, interesting name. So, how do you define the joint limits, the obstacle avoidance, and the path? Did you use a behavior tree for that?
No, this is completely below the behavior trees, right? So the behavior tree can do high-level planning. So at everything that I showed here would kind of be below the behavior tree, right? The tree would say, hey, go plan. Did it work? Good, run it. Did it not work? Okay, try something else. But these are all like self-contained motion planning algorithms. As far as the joint limits and obstacle avoidance, these can be defined in two different places, right? So we talked about the URDF description. So if I look at the UR gripper, as one example, you see that all of the links that you create in your URDF actually have collision geometries that could point to things like meshes or geometric primitives like rectangles. See here you have like, somewhere in here you have collision boxes for the gripper, for example. That's one way. Actually, in URDF also has a way to load some joint limits. If I search for a joint, for example, you see here the wrist2 joint has certain limits encoded for it for like maximum effort, position, and velocity. But if not that, you can also, ignore the URDF and use your own limits based on the knowledge you have for your robot. Like maybe the manufacturer said these are the limits, but you want to run slightly slower for conservative. So I think most tools let you either read from the description file or bring your own limits. Same for obstacles, right? You can have the obstacles live in the URDF, or in the case of one of these other examples, we actually let me go to a different example here. Oh, sorry, I'm not sharing my screen, am I?
Okay. So I was trying to talk to my team to show your screen because it was not showing there. I thought it was on our side. So it's
no, I will.
Okay.
I'll leave it at that. So URDF contains information, but you can also add it programmatically. Let's move on in the interest of time.
Okay. Then another question from Nikita Emolenko. Then she says, are there any established algorithms for almost Cartesian planning? She has encountered some problems with real manipulators that struggle to execute perfect Cartesian movements. However, the task doesn't necessarily require perfect lines, and some deviations are acceptable.
Yeah, there's lots of, so at the end of the day, the big reason that Cartesian planning fails is because you don't need your inverse kinematics to meet exactly, like you said, the Cartesian trajectory at every point. There are some algorithms that let you parameterize this easily. One that I keep hearing about lately is called relaxed IK, which lets you, as its name suggests, it lets you relax certain constraints. You can also, this is really where the world is going nowadays, but trajectory optimization also lets you do this, right? Where instead of having like hard constraints on a trajectory to like exactly meet them, you can create either soft constraints or not even have them as constraints, but only to formulate this as a minimization problem. So like give me any valid trajectory that minimizes my distance to the desired Cartesian path, and then it's up to you whether the solution like meets the requirements or not. So there's lots of different ways. I think at the end of the day, it's either getting IK solvers that allow you to express relative tolerances in different parts, or relying on other things like optimization, or even the learning-based approaches. Going back to Robert's question.
Yes. I also agree that I think that so it has to go into the direction of learning. I don't see how the proper mathematical resolution and computation of the trajectories can solve this problem, and especially when we have to apply into a real environment where other things can appear at the very moment, and then we have to avoid those things or change the trajectory in some cases. I don't know. What are your thoughts about this?
Yeah, there's one more thing I want to share there. This goes back to actually Goet's question about behavior trees as well. There's something about like when you're trying to run a Cartesian path, you're assuming it fails because you're only giving it one chance to do the path, right? But what you can actually do is if you get yourself stuck like halfway through the path, you can lift off the arm and you can rearrange it so that it's in a better position to finish the second half and then go back in. And this is done very commonly in these like large scale applications. Like if you're trying to like weld an entire airplane wing, like you can't do the single Cartesian path because the robot's workspace is way smaller than an airplane wing. So you actually do have to like do it in pieces. And then it becomes an optimization problem or like a behavior reactive problem for like, how few times do I have to readjust so I can do the whole task?
Okay, then thank you very much, Sebastian. I think that we have to finish here because of the time. Thanks a lot for the awesome project that you have prepared and the presentation. Thank you very much.
Thank you for listening.
Thank you. Bye-bye.
Yes, thank you, Sebastian, very, very much for that very nice presentation. Guys, remember, the rating box should appear now at the chat. So remember to rate the speaker because 2 more left before we pick the best speaker of this year's conference.
Wow, perfect. So before the next speaker hits the stage, let's have some fun.
One more time?
Yes, we're still doing the quiz prize. Yeah, we're still doing it.
Okay.
The winner is going to have the Super Sweat box with the I'm a Robotics Developer t-shirt, coffee mug, and stickers. So this is sponsored by the third-party ROS project by the constructs. So it works the same. Now we're going to watch a 5-minute video related to the third-party ROS project. And at the end of the video, you will see the question related to it. And the first person answers correctly in the chat will win the sweat box. So you may need to go to the page of the sponsor to get the answer. So now let's watch the video and we will see the next speaker in 5 minutes. So see you soon.
All right, welcome back, everyone. And
What is? Hey, hello. Hello, hello. Yes,
who's up?
let's go.
All right, guys. So thank you for participating in that contest. Before we announce the winners, we want to mention a quick revision. Ricardo?
Oh, yes. Yeah, because it happened in one of the previous contests that we did in order to win the swag. So there was one, the winner, he was just typing answers there randomly, and then it happened that it wrote the correct answer before time. And then we accepted this as the correct answer because we didn't check that. But then afterwards, there has been like a discussion over there. The winner himself, he has proposed to say, "Oh, please, yes, you are right. So this is not fair for the real winner." And then he refuses to receive the prize, and then he's very willing to accept the second position. So let's move to the next winner, and the winner of that swag box is Chloe Dutil.
The previous one.
Yes, on the previous one, yeah? On the previous one is Chloe Dutil. So the previous winner, he is not accepted to get the prize because he doesn't consider that this is fair. And then the next one who had the proper answer is Chloe Dutil because it was about the Botbox project and what it was the difference. And the difference were the students' licenses access to the courses. Okay, so that's basically. Then now, so we have corrected problem from the previous one, and now let's go for the winner for this last bot box. Swag box.
So very nice of the previous winner.
Yeah.
So and this round, who wins? Let's see. It's Luigi Feola. Congratulations. So yeah, we will contact you for the ship details.
Yes, you only needed to go and check the number of ROSEC because it's published there, and then that was correct. Great. What else?
Great, so now it's time to get hands-on again.
Hands-on? No. Hands-on?
Yes, let's get hands-on again to build your robotics portfolio for better job opportunities.
Okay. Yes. So let me see what is the situation. Yes. In today's competitive robotics field, showcasing your skills effectively is a key skill that you have to master in order to land your dream job. This workshop will guide you step by step on how to show your robot projects and achievements to stand up to employers. Let's welcome Miguel Angel Rodriguez, the head of research of the construct, where he's going to show us how we can craft a strong portfolio that boosts your career prospects in robotics. Miguel, how you doing?
Hi, Ricardo. Nice to be here.
Okay, excellent. Are you ready? Let's have
I'm
a look.
ready.
Yes,
I'm
we
ready.
can see you now. Excellent. So then the audience is all yours. Go ahead.
Okay. Okay, so thanks, Ricardo. As Ricardo mentioned, I'm the head of research in the contract, and I'm going to try to give you some insight and some tips on how to develop your robotics portfolio, which I think it's one of the most important parts when you're starting to look for jobs in companies, in research, whatever you need. So I think it's vital nowadays. So I hope everybody can see my screen now, what I'm sharing there.
Yes, we can see it.
Okay. Okay, so let me start. So the first thing is what is robotics developers portfolio? So it's essentially your space to showcase your robotics work and get hired for it. The main purpose of the portfolio is to show the others what you have accomplished in robotics so that they can evaluate your work and decide if they want to hire you or not. It should be, for one, a page ready to be sent to any job offering, opening, or whatever. So it's something that it has to be easy to share. It should help the recruiter quickly decide if you fit for the job or not, and also trigger some questions for the interviewer, which it's easier, and it will be the main topic of all this workshop and what I'll be talking about, which is lowering friction for the recruiter. The lower the friction, the better, and higher possibilities you have to get hired. And also, it should show professionalism. So no doodling, no web pages of Windows 95. So something that shows the level that anybody hopes for an engineer in 2024. Okay. So the first thing is, okay, Mike, but I mean, I have my curriculum. Why do I need this portfolio, you said? Well, there are several reasons, but you can here see the most important ones. First, everybody lies in their curriculum, and that doesn't mean that you put very big lies, but normally we tend to decorate the things a bit better, and we try to sell us better than what it really is. Sometimes we don't have the concept of those skills, if they are so valuable or not. That's one thing. Then actual experience matters in engineering jobs. Actually, experience matters above practically anything. So you can have an education that it's not that high level, but maybe you have a lot of experience, and normally engineering jobs prefer that. So having a lot of experience in whatever you're applying to, then it shows your professionalism to the recruiter. So it shows that you care about your image, your professional image, and to show the work that you've done. And then finally, it simplifies the life of the recruiter, as I said earlier. The portfolio shows what you're capable of and essentially help the recruiter, the job that it has to do, basically that. So what should include the portfolio? The first thing is common sense. So it has to have the information, personal information, so that the recruiters can contact you. Normally, when you're sending your portfolio, the recruiter at least has your email or something like that. So at least some way, but you have to open the channels where the recruiters can contact you, like Twitter, Facebook, GitHub, whatever. If they can't contact you, they can't tell you you're the so awesome person and engineer you are. So that's the first thing you have to add. Then the second, and it's one of the most important parts, is a collection of robotics projects. So show a selection of your best projects. More doesn't mean better. So the best ones. Those projects must represent your skills, abilities, and the quality of your work. So those projects, they might be not very practical or some, but they have to be a demonstration of what you're capable of, your maximum potential. Then the third thing that it should include is contributions to open source projects. And that's something that, from my perspective, I thought, why do I have to contribute at the start? And throughout the years, you discover that when you work in a company, most of the code that you do is not public, which means no one will ever know the fantastic code that you wrote 2 years ago. So that's one of the reasons why contributing to open source projects is very important. And also, contributing to open source projects requires a set of skills that
potential employees always look for, like knowing how to work in a team, knowing how to manage a project, everything. All those skills are concentrating on the fact that you contributed to open source projects. Then you need a summary of experience, which is basically your working experience, if I worked there, and so on. The most important part of here is that you don't have to put all your work experience, only the work experience that is relevant for the job post that you're applying to. So if it's relevant only one thing, then put one. And the reason is, again, lowering friction for the recruiter. The recruiter doesn't care if you worked in a pizza restaurant 5 years ago, unless you're applying for a pizza job, okay? So be simple and put only the information that is relevant. Then summary of education, again, only the things that are relevant. So skills, I know how to play the guitar, but it's not relevant for my job now. So only put the skills that are relevant. And languages, of course. And finally, the list of certificates. So just show the latest education you got relevant to the job. Again, not all the certificates of your life, only the ones that are relevant for the job post. Okay? So how can we create one? The first step is obviously, and the most important part is, oh, by the way, I forgot something. So from these 6 points, the ones that are compulsory that you have to put are the first 3. So contact information, the collection of the best projects, and contributions to open source. The 4, 5, and 6, experience, education, list of certificates, it's a good to have, it's not a requirement in portfolios. Okay, so how can we create one? The first thing that you have to do is select the most important projects. And those projects must represent your skills, abilities, and the quality of your work. If you just have one, then put a single one and not more than 6. And the reason is, again, reduce friction. If you put 20 projects, the recruiter won't know where to start, and it won't concentrate his attention in the fantastic job that you've done. So it's much better that you just put a single one, the one that is most relevant for the job that you're applying to, or you're looking for, or just the topic that you're most interested about. Then, second step is you have to create a good thumbnail and pick a title for each one. And as an engineer, I understand that this, for us, is a bit difficult at the start. So why do I have to spend hours picking a thumbnail and a title? I'm not spending my time where I should, and you'd be wrong. Even if the recruiter is a very well-versed engineer, presenting your projects in a graphical way that anyone from your wife, your friends, or anyone that doesn't know anything about it understands is key, even for engineers that know a lot of stuff. Okay, so it's absolutely essential. So please get your YouTuber spirit and generate good thumbnails. Then the third step is you have to create good documentation, and I can't stress this enough. Documentation must clearly indicate the following. First one is what is about. What's this project about? This project that you stated here, which it might be only a single one, okay? So what it's about. Then the next one is which problem is it solving? Which results are expected? And third, how to launch the code to obtain the claimed results. And I can't stress this enough. There's loads of projects around, hundreds, thousands of Gits and projects everywhere in the internet, and no one uses them. And they can be fantastic, fantastic coding, fantastic. But if the person that opens that project doesn't understand how to use it, it's absolutely useless unless you generated the tool that it's the single one in the world and they need to use it. Then they have to look into your code and have a look. But for a potential recruiter, he has to go fast. And that means making it very easy and lowering the friction at the maximum. Then the fourth step is provide source code and a way to replicate results. So this is, if possible, include a video, the system working. You can upload it to YouTube and put the links in the instructions. But essentially, provide a way to the recruiter to test and feel the project that you've done. That has a lot of power to selling your projects. You can't imagine how much power this, and you've seen it throughout the day, that the presentations that give real results and show you things in the real robots, even, they have very big impact on your memory and understanding of what you're doing. And then finally, add all other personal details like experience and all that stuff. As I said, this final step is optional. It's a good to have in the portfolio, but not necessary. So where should you host it? There are mainly, I would say, I'm going to talk about 3 ways of doing this. The first one is Git. And this is no-brainer, because actually, if you're a good engineer, you'll be working in a Git of, like, let's say, GitHub, Bitbucket, GitLab, or whatever. So this comes automatically. The good things is that you'll have it for when you work. The disadvantage of this is that the recruiter will have to download the code to test it. And that's complicated because each one has different computers. Your code might break the recruiter system, which that would generate a very bad impression. So it's a good place to start, and I would say the easiest one. Then the next one is generating your own personal page, self-hosting it. And the advantages of this is that you have full control on what you include, what you don't include. And the disadvantages is that you need more experience, more time, and spend time or money on generating this personal page. And as a side note, make it mobile friendly, because most of the recruiters will see your portfolio maybe in their mobile phones. So I've seen a lot of portfolios that look very nice and web page and desktop, and when you see it in the mobile phone, they're total rubbish and you don't understand anything. So take care on that. Then another option is one that we give here in the construct, which is it has all the features that I've talked about previously, but also it allows, one of the best ones is that it allows the execution of the projects online by the recruiter. And just by pressing the button, you don't need to download, you don't need to install anything, and they can use any computer to check the project. And that's a massive selling point, because it's, again, reducing the friction to the recruiter. That's one thing. And also another thing is that you can put there your code, make it work, and then forget about it. Because I'm sure all the engineers that are hearing this, how many projects you've done, you've left them in the Git, and when time goes by and then you return, you try to download it, execute it, and it doesn't work. So one advantage of hosting them in the contract is that they will work forever. And that is a bonus for sure, because when you have to make your portfolio fast because you want to select certain projects for a certain position, they have to work, and you can't spend days and days and days making them work code of 2 years. And also this integrates with ROS job listings page. And as a side note, we don't recommend, for example, LinkedIn, because LinkedIn is more focused on resumes, curriculums, and the hosting of projects is a bit dodgy. So we don't recommend that one. So again, the contract, you have a very good option there. So I can show you mine, for example. Let me click here. There we go. So again, you can see here that I have the personal information. I have the 6 most important projects that I'm more fond of, like for example, AutoWare. We did a test about this. We also did ROS2 with Godot, Tic-Tac-Toe, Quadruped, the rover here, also our projects in fleet management, and I have them here. I just click here, run, and it's good to go. And then we have also all the experience and my certificates and so on. And also you can print your curriculum, and it just prints, and you have a curriculum just for the laughs, I suppose. Okay, let me return to there we go. And again, I wanted to also give an example of one of our master's class students, Miguel Solis, portfolio, which is amazing, and he's hosting it in a web page. And this is amazing because he showcases all the projects that he's done throughout the masterclass, most of them. And as a recruiter, I would say, okay, which one do I pick? And you can see here, he's using images, videos to sell. And it's very descriptive of what he's doing, designing the kinematic model of ROSbot XL, doing the 3D kinematic analysis and control. It's very clear for me, and I don't know this guy, and I don't know what his skills are, but I'm seeing that he's serious and professional, and I know more or less with a glance what he's capable of. So as final conclusions, what if you don't have projects done yet? Then start right now creating one. And this is fundamental. If you want to get a job in engineering, in robotics, whatever you want, you have to have working experience. So select a topic that you like, that you love, and start a Git. Create a Git and start your project. That's one thing that you can do. Another one that could be complementary is contributing to an existing open source project by solving bugs, by adding features, by suggesting improvements. And the best way would be to combine both of these things. So you create your own project about, I don't know, I love a humanoid robot and I want a humanoid robot that dances, I don't know. Then I look for open source projects that I need for my project, and I fix bugs, and then I go there and do pull requests. And doing this, you'll generate a project that you love, that you can put in your portfolio to showcase your quality, your skills, programming skills, robotics skills, whatever. And you're doing something that you love and you can show with passion. And I can assure you that if you have a portfolio with a project that you are passionate about, it will be very well done, very well documented, and someone that shows passion about a project, it's a plus when it's in a recruiting selection race. And that's it. I finished like 9 minutes before, but I think.
Excellent, Miguel Angel. You have reached the questions stage now. So thank you for your presentation, Miguel, and for clarifying some points about how to get a good portfolio. And now it's time for the questions from the audience. And you know that there is a Q&A tab that is on the chat on the side. Then you can put your questions for Miguel there, or both the ones that are already written, and then I will ask those questions to Miguel directly. Also, a round of applause. Yes, I like this applause thing on the thing on the platform there. It's cool. Great. Then one question from Juan Rodriguez. He says, "How many pages should a CV have?"
Okay, very good question. One, yeah. As I said, curriculum or portfolio, but they have to be concise and to the point. And if you have like 3 pages, the recruiter will get bored. They have to see hundreds of applications. You have to concentrate your information that you give. So I would say one. That's it.
Okay. And another question from Shivam Chudasama that says, "If you are a fresher with a relevant internship experience, what shall we do to boost our chances?"
Okay. First of all, there's no irrelevant internship experience. I think that anything that you do is relevant. So that's one thing. And second is, as I said, pick a project that you're passionate about, okay? And you can do it in your free time. You can look for open source projects about this topic and start working. No courses, no nothing, okay? I would recommend that you do courses when you need them. So I'm doing my project, my passionate project, and I need to know about inverse kinematics, and I do a course. But do a project that you're passionate about and do it public. And that forces you to be better engineer. And you'll see that in very little time, people will be interested in your project. That's my advice.
Yes, and also let me share also the comments that Professor Jack Silberman shared with us about this thing. If you don't have any internship experience or whatever, go and do an internship. That's what he was saying. Then go and do an internship in a relevant field. And for that, maybe you have to do this for free. Yes. So you go there and then you provide value to the person that is providing you this internship. It has to be a valuable internship for you, I mean, in the line of your career. But if that's the opportunity there, then you should go and do it. In this case, like this, you are going to build your portfolio. You are going to have your internship experience. And then you can boost your chances, as he says.
Mm-hmm.
That was expressed by Professor Jack Silberman before, some talks before. Let me ask you another question.
Sure.
Then is for Ruji Osama, that he says, "I am a robotics student at the 4th year. Should I work on a portfolio? Maybe oriented to internships," he says. Oriented for internships, maybe?
Internships.
Should I start working right on the portfolio?
Yeah, so you have to start with a project and then you generate a portfolio. But I mean, you're in 4th year and I suppose you're finishing in 1-2 years. So start working in your passion project. For example, I started in robotics when I was, around there. And I went to the ED there and I did a project on humanoid walking robots. I didn't post the code and I did wrong. So do the work and post it publicly and put it nice with good documentation, videos, and so on. And that can grant you an internship in somewhere because they'll say, okay, this person has experience in this and this topics. So it's better than doing your studies without doing anything, and then you're imagining that when you finish, someone will recruit you. If you don't have prior experience, it's more difficult to get an internship sometimes. So,
or a job. Yes, actually, that's what also the Luca and Sai were saying at the beginning of the conference, about the importance of having a portfolio of things done that you have done. Yes. Then I have another question from Rodrigo that says, do you recommend to showcase many projects or just a very few strong ones?
I recommend one, maybe 2 or 3, but they have to be not like 20 or so. I think they have to be relevant to what your interests are of applications or work, because if you're applying to, for example, PAL Robotics, maybe the projects on control, projects on biped robots are relevant, and maybe AI related projects maybe are not that relevant for the job post that you're applying to. So I would say very few, from 1 to 3, maximum 6.
So that would be the strong ones, right?
Yes,
The
exactly.
strong ones. And then Andres Leonardo is asking, should I add papers or prices to my portfolio?
Good question. So again, if they're relevant for the application, for sure. Papers are a bit, prizes, I would say, okay, yeah. It's like education, it's good to have. Papers, a bit higher, especially if you're applying for research that has higher value. But again, papers have this drawback that there's no demo or code that shows anything. And sometimes reading a paper, it's a bit complex, difficult for the recruiter. So I would say if you put papers, put a link to your documentation with demos and videos. I think that would sell the paper much better. That's my opinion in there.
Okay. And then very simple question, maybe you can show to our winder that says, how do you host your portfolio on the Construct? I think it was not quite clear.
Yeah.
Maybe you can share your screen.
Let me share a screen. Okay. Can you see my screen?
Yes.
So you can see here that in the main page, you just go to your profile. That's it. That's simple.
Yes,
And
that's simple. And then press the pencil, right?
Yeah, you
For
press the
edit.
pencil here and you edit all the elements that you want to edit, like here. And then these guys here, the projects, what you have to do is you have to go to your projects and then click on a project, for example, this guy. And then you see this one, I have it there, posted. And maybe let's remove this one. So when it's not added, you just go to these 3 dots here, and then add project to showcase. That's it. And then it should be in your profile. So it's really, really easy. It can't be more easy than this.
Yes. Okay, then thank you very much, Miguel. I think that we are going to stop here and thank our speaker again. Thank you.
Thank you.
Some applause. Thank you very much.
Thank you, Miguel. And you know what happens after the speakers, guys. Make sure you go on the box for rating and rate Miguel here as the speaker, because we got one more speaker, and afterwards we're going to select the best one of this year.
All right, so here I am again. I know that you know that we're gonna have some fun.
Do you promise is the last one, Chess?
Yeah, I promise. So let's
All right.
do the last prize quiz of the day. The winner is going to win our last super swag box with I'm the robotics developer t-shirt, the coffee mug, and the stickers. So you're gonna watch the last 5-minute video about Usarian as the sponsor. And at the end of the video, you're gonna see the question related to the project. And the first person who answered correctly, you will get the sweatbox. So as always, you may need to visit the page of the sponsor to get to the answer. So now let's watch the video, and the last speaker will be back in 5 minutes.
See you soon. All right, welcome back, guys. How was that quiz? So, before we announce the winner, there isn't, let's get ready for the final presentation, which will be the last hands-on learning session. Click on the Open ROSject button next to the speaker's name, and the project should open in some seconds. And while the project is opening, let's go over about what happened in this last quiz, huh?
Yes, that unfortunately nobody got the proper answer.
Yeah.
So yeah, so that's maybe too tricky for finding the answer. And the answers are the Universal Robots, Dobot, and Kinova robotic arms from the official page of Fusarion, but from the store of Fusarion. But it's a little bit tricky. You have to go to the bottom picture of the robot and then click on one of the joints of the robot, and then you will see that this information. So it's a little bit. I think that we put it too much complicated in this case. Dobot.
So Dobot was the one that we were
Miguel
looking
Solis,
for.
no, not Cobot, Dobot. Miguel
Let's try
Solis
that.
would try, so he just put an answer what we said.
All right.
So it's unfortunately, so this is going to remain open. So now, what do we have next?
It's our last final hands-on session.
Oh, excellent. And what is this last hands section? Is about let me check because yes, so yeah, oh yes, with Alberto, yes, we are going with Alberto. So yeah, probably you know that every year there is a new release of ROS2, and this year has not been different. So we have the release of ROS2 Jazzy, and with this conference, in this conference, what we want is to provide you with the first insights about the improvements that you can experience if you change to ROS2 Jazzy. And for that, we have Alberto, who is the head of education of the construct, and he's going to do a review of ROS2 Jazzy and tell us the most important or interesting things that you can find if you decide to install ROS2 Jazzy or you are considering about migrating from a previous version of ROS2. Alberto, are you there?
Hello, I am here.
Yeah.
Can you hear me?
Yes, we can.
All right. So, yeah, hello, everybody. I want to start by saying some quick words. So, this is the last workshop of the conference. I know there's been many hours of amazing talks, workshops, learning sessions. This is the last one. So, let's finish with energy, okay? Let's finish with good energy this conference. Then I'm going to be doing a light presentation. We are going to have a project where we are going to be able to do some cool demonstrations. And then also stay tuned because at the end, I am going to be connecting to the real limo robot, to the real limo lab that we have here in our offices. And I'm going to be testing some of your projects one by one, and depending on if it works correctly or not, selected randomly, but testing your code in the real robot, and then we will see who wins the limo challenge and who wins the limo robot. All right. So yeah, without further ado, let's get started. Let me start sharing here my screen. There we go. All right, so I hope you all can see my screen here. And yeah, so today we are going to be having a quick overview of some of the new features that have been added with the latest ROS2 release, which is named ROS2 Jazzy Jalisco. And there are many features, many things that have changed with respect to the previous version, which was Iron. Here I have just selected a few that I think are interesting for, can be interesting for developers. And yeah, we are going to be reviewing them. So my name is Alberto. I am the head of education at the Construct. Probably some of you already know me also from the open classes. or from the masterclass. And yeah, so let's already jump into the action. So Jazzy Jalisco, as I was saying, is the latest ROS2 release after Iron Winning. It has been released barely a month and something ago, May 23rd. And one important thing about Jazzy is that it is an LTS release, which means long-term support. Yeah. So this ROS2 release is going to be supported until May 2029. Yeah. So it's 5 years. Then why I'm saying this? Because maybe if you have some old code, this is a good moment to migrate it to ROS2. All right. Or even if you have ROS2 code, but in an old version, I don't know, maybe Foxy or something like that, this is a good moment. This is a good release because it's going to have a long-term support, right? Then here I have also added a link to the full official document for the release, in case that you want to check all the different things that have been added, modifications, and so on. The supported platforms are the same as for the previous versions. So the tier 1 platforms are Ubuntu 24, well, Ubuntu 24, Noble, and Windows 10. There are some tier 2 and tier 3 platforms also, like Red 9, macOS, which are supported experimental, let's say. Yeah. Then the first thing I want to introduce, and the first thing that I want to talk about in this workshop, is about the Gazebo SIM integration. Okay, so far it has been a bit messy to integrate ROS2 with Gazebo. In the latest releases it was a little better, but especially in the old ones like Foxy, it was a complete mess. So now, starting from Jazzy, starting from this release, there is going to be a Gazebo SIM release associated to every ROS2 release. For example, in the case of ROS2 Jazzy, the associated Gazebo release is harmonic. All right. This is a concept which is similar to what we had in ROS1, where every release of ROS1 was associated to a Gazebo Classic release. All right. Then, in order to achieve this, what has been released are the Gazebo vendor packages. Here you can see a list of all the packages. And basically, these packages, what do is to provide by default. Yeah, so when you install ROS, when you install ROS2 Jazzy in your system, you are going to already have this by default. Yeah, and these vendor packages, what do is to provide all the necessary Gazebo libraries for ROS. Yeah, then let's start by opening a shell and have a look at these packages. We are going to be able to find them here already installed. So let's open a new shell. At this point, you should already know how to do this, even though I have also explained it here. Yeah, also, for me, it did not open automatically for some reason, but whenever you open the project, probably for you, this has automatically opened and runs. And this is going to install some packages. There we go. All right. Then let's try to execute this command. Very simple, ROS2 package list. And we are going to filter to see what packages we have installed in the system with the GZ characters. And then we are going to be able here to see that we have all these vendor packages installed. Yeah, all this has been introduced in Jazzy. And the goal of these vendor packages is mainly to make this integration between Gazebo SIM and ROS2 much more smooth. All right. So, for instance, we can run. Okay, let me do stop a moment here, because I have noticed, and this has happened to me several times as well. There is a bit of confusion between all these Gazebo different names. So I decided to include here a simple graph. Yeah. So we have Gazebo here, the one at the left, which is Gazebo Classic. Okay. Then at some point, this Gazebo Classic evolved, let's say, into what was known as Ignition Gazebo. Yeah. And then now, in the latest years, Ignition Gazebo has been rebranded to Gazebo SIM. which is this one in the right. Why am I saying this? Well, I am saying this to clarify all the naming issues between the different Gazebo versions, but also because as of ROS2 Jazzy, Gazebo Classic is no longer supported. Sorry. So what does this mean? If you still have simulations working in ROS2, which are based on Gazebo Classic, probably this is a good moment where you should start migrating your Gazebo Classic simulations to Gazebo Sim. Okay, because as I'm going to repeat it, as of ROS2 Jazzy, Gazebo Classic is no longer going to be supported. All right, here I have also left a link to a guide, official guide of the Gazebo Sim documentation on how to migrate Gazebo Classic ROS2 packages. All right. Okay, then let's start running some things. So as of ROS2 Jazzy, starting the Gazebo Sim simulator is as simple as sourcing the ROS version and running Jazzy Sim. We can do it here real quick. Then this might take some seconds, just be patient. And eventually we are going to see here, we should see here automatically appear the Gazebo Sim simulator homepage. There we go. Okay. And this is, yeah, so this is basically the Gazebo Sim homepage. You can see several different simulations here that can be selected to start. For instance, let's select any. I'm going to select this one and click on the Run button. And then this is going to open the selected simulation here. All right. One interesting point about this is that let me wait some seconds until this finishes loading. Okay, there we go. So we have to click on the play button here to start the world and the physics and everything. And then you can scroll down if you want, and for instance, control the robot here with the keys. Let me maximize this. There we go. So I can, yeah, for instance, click on these buttons and start moving the robot, okay? Now, if we open a second terminal and we execute, let's say, a ROS2 topic list command, we are going to see that no topics related to the simulation are there. Yeah, just the default parameter events and ROS out topics, okay? Why? Well, because this simulation that we have started is a Gazebo Sim simulation. Yeah, it has nothing to do with ROS2 at this point. Okay. Then, in order to start Gazebo Sim integrated with ROS2, we need to start some specific packages, like for instance the ROS Gazebo Sim and so on. Okay. Now I'm going to show you an example here. Right below, we have an example, okay, of a launch file where we are starting Gazebo Sim integrated, connected with ROS2, right? So it's this command here, the gc ROS2 control demos diff drive example, okay? We can copy this command here directly from the notebook as well, and then execute it here. Let's wait some seconds. And here we already can see in the messages that some controllers are being loaded. All this is already ROS-related stuff. Yeah. And here, not here, sorry, now in the simulation window, we have the Gazebo Sim simulation. But now, if we go again to the shell, to the terminal, and we type again ROS2 topic list, we are going to be able to see all the topics related to the simulation, like the command belt topic to move the robot. Yeah, I think I even added a, no, not here, it's later. Yeah, so we have all the ROS2 topics which are associated to the gazebo sim simulation that we have just launched. Yeah, if you want, we can have a quick look here at the launch file. Okay, I'm not going to go into details because that would be too much, but we can have a look at this launch file. So let's open the code editor here. Also, you should already be an expert and know where everything is in this project. So I'm not going to stop to explain it. And here, if we go inside the ROS2 workspace, you are going to find several packages, between them these GC ROS2 control demos. Yeah. So inside this package, if you go inside the launch file, you are going to be able to locate this diff drive example.launch.xml. Yeah, here we have it. Yeah. Then here you are going to see exactly what it's being launched for this simulation. Yeah. So you can see the ROS GC sim package, the ROS GC bridge, the controller manager, etc. Yeah. Then I am showing this because one thing that is currently in development, and it is expected to be released for ROS2 Jazzy, but it's not yet finished. It's an integration between Gazebo Sim and XML formatted ROS2 launch files. Yeah. So far you can create ROS2 launch files in XML format, which are pretty simple, as you can see. Yeah, you have to specify some nodes like ROS GCSIM, create, and you can specify directly the topic where to get the URDF information from. So all this is quite simple, but this is going to be simplified even more. Yeah, so they are working on some special tags like the GC server GC server, the ROS GC bridge, where you are going to be able to load the configuration file directly to the using just a simple XML tag. Yeah, so this is some work in progress. Okay, and for what I have been reading, it should be released soon. It is expected to be released with ROS2 Jazzy, but it's not yet ready. Yeah. Okay, so yeah, this is so far what we are going to cover about this gazebo sim integration, which is very, very interesting. Now I want to move to some more simple examples, let's say, based on command line tools. These are things that we can you can start using from today. Okay, so if you are developing in ROS2 Jazzy, this is going to come in handy for sure. So we are going to see a couple of examples. First of all is the possibility to generate custom log file names. Okay, so probably you don't understand what I mean with this, but let's see a very, very simple example to demonstrate this. Okay, so we are all going to go to the cd.ros/log. This is the default directory where ROS puts all the log files. Okay, so if we come here, let's come here. I have the simulation here. Okay, so let's leave the simulation running in the first terminal. Let's not close it. I'm going to actually write here something, I don't know, sim, so that I know that here I have the simulation running. And then here, if you go to the home user.ros log path and run an ls command, here you're going to find maybe some folders, some log files. Okay, so let's just remove everything. Yeah. Yeah, let's remove everything from here until we have this directory empty. Yeah, so we have just cleaned all the logs. Okay, so now what we are going to do is to run the following node. Okay, this is a very simple node. You can find it here also in the workspace if you want to see the contents, but just as a very stupid example. where basically we are subscribing to the autumn topic and printing the information of the XY coordinates of the robot. Some very simple program. Then if we run this program by the regular ROS2 commands, all of you know these commands, yeah, ROS2 run, this is the typical way, well, ROS2 run or ROS2 launch, it depends. But if you want to execute a node quickly, probably you are going to use the ROS2 run. Then if you execute this command, there you go. And then let's open a third terminal here. And we are going to go again to the .ros log. And you type on ls again, you are going to see a log file has appeared. All right? You can check it if you want, the contents, and you are going to see that the contents of this file is basically the output of the program I have just executed. Okay? So far, so good. This example seems pretty simple, right? But this can become a mess when you are executing many nodes, many programs, etc., and you start getting this folder, plenty of log files where the names are all basically almost the same, right? So all the log files are going to be named Python 3 whatever, yeah? So, okay, how can I differentiate this one from this one? No idea, yeah? So one cool tool that ROS2 Jazzy brings in is the possibility to actually provide a custom name to these log files, yeah? And it is very simple. It is as simple as specifying the argument log file name, yeah? So now, if I execute this command instead of the regular ROS2 run without any other argument, let me run it here. ROS2 run, so same command, but we add the ROS argument log file name, and here we specify the name. For instance, my logs, but you can put here whatever. If now I execute my program again like this, the log file generated is going to be named like this, my logs. So I can clearly identify this log file corresponds to this program that is being executed right now. Okay, so a simple thing, but I think it can be very interesting, especially for debugging programs and so on, right? Then let's move quickly to the second one. Also a very simple thing, but very important at the same time, yeah? So all of you, if you have worked with ROS2, you know about the ROS2 topic list command for sure. This is known by everybody, but also the ROS2 topic info, right? So if you want to get information, you use the ROS2 topic info command, right? And then you get information related to this topic. So what is the type, how many publishers are publishing into this topic, and how many nodes are subscribed to this topic, yeah? Very typical day-to-day ROS2 tool. Now, maybe you didn't know this, but for services, there is no ROS2 service command, right? So there is a ROS2 service list command, as you can see, where I get a list of all the services that are currently available. But until ROS2 Jazzy, the ROS2 service info command didn't exist, yeah? I have added here a small note with the output that you would get, for instance, in Humble or in Iron. If you try to run a ROS2 service info command, it didn't work, yeah? It was not working. So in ROS2 Jazzy, this command has been introduced. Yes, so let's try it out. Then for this, first of all, we need to, I'm going to start a service, yeah, that I have created here, a very simple service. So we are going to run it here in our second terminal, right? Let's copy paste it here. And then this, yeah, this is the service. Okay. So now, sorry, if we do a ROS2 service list, we should find here this start track post service and stop track post service. Yeah, these two services are provided by this Python script that I have created here. Yeah. Then now we can very conveniently just run the ROS2 service info command in order to get information about a specific service. Super useful. And the information I get is the type that this service uses, which in this case it's the trigger type. And also I get information about how many clients this service has and how many servers. Yeah. So servers are going to be 1, but clients, we can see if some client, some node is right now requesting something to this service. Yeah, this can be also very useful for debugging. So for instance, if we try this, I'm going to call this service here from another terminal. Actually, we are going to have to open yet another terminal, but it's the last one, I promise. Yeah. And this is the last terminal that we are going to be opening. Okay, so yeah, okay, there we go. Here we have the service still running, and then here we have the ROS2 service info, okay, which is showing 1 service and 0 clients, right? So now what I'm going to do is to call this service from another terminal. Yeah, calling a service basically means creating a client. Yeah, because a node that calls a service is a service client by definition. Okay, then if I call this service and I run again the ROS2 service info, I get 0 clients. Why? Well, very simple. Because the service call was too fast, so I have not been able to detect it. Okay, then what I'm going to do here is to change to another to call another service, which is the stop track post service. Okay, by the way, all this is making the robot move and stop. Okay, I'm not showing it, but yeah, whenever I call this stop service, the robot is going to stop moving. Okay, then here what I'm going to do is to call this stop service, because here inside the process of the call I have placed an sleep so that we are going to be able to detect the client. Yeah, so let's call the service, and now if we run the info command, we are going to be able to see that this service has 1 client. Yeah, and when the call finishes, which is right now, if we come back, we are going to see that the client is now disconnected. Okay, this is a very simple thing, but very, very useful, especially for debugging, and especially because services are an essential tool. Yeah.
10 minutes.
10 minutes only? Okay. Let me keep going. Okay, then we are done for these command line tools, and we are going to jump into another very, very important topic, and one of the biggest things for me that come with ROS2 Jazzy, which is RMW Zeno. Okay, let me stop at this moment. Before starting with this demo, I want you to close all the terminal. Okay, so at this moment, just stop all the programs. And in fact, what we are going to do is to stop the simulation as well, everything. And we are going to close the terminals, okay? I want all of you to start with brand new terminals, okay? So, sorry, there we go. All right, so what is RMW Zeno? So if you've had some experience with ROS2, probably you are aware of the DDS concept, yeah? And you know that under ROS, there is a DDS implementation, yeah? So here I have added a basic graph, which shows a little bit this, yeah? So at the top level, we have the user application, which are the ROS2 programs that we create, right? In Python, all these. This would be the higher level, which is the user application. Then behind this, we have the client libraries. Yeah, the specific ones, which are, for instance, RCL CPP, RCL Py. Yeah, if you are creating nodes in Python, then you use the RCL Py client library. If you are writing nodes in C++, then you use the RCL CPP. Today, also, we have seen the RCL RS for Rust. There is also another one for Java, etc. Yeah. And then behind these client libraries, we have the DDS implementations. Yeah. Usually in ROS2 by default, you are going to be using either Cyclone DDS or Fast DDS. Until now, okay? So now there is a new middleware implementation that has been applied, that has been added, which is RMW-Zeno. Yeah. And what is the purpose of this new DDS implementation? Well, basically the purpose is to make things easier for developers. Yeah. So when you are working with ROS2 at a beginner level, you might not notice all this, but whenever you start getting into more complex stuff, if some of you have done this, you probably have had some kind of problems with the DDS implementations. What kind of problems? Well, the typical ones are discovery failures, especially, for instance, if you are trying to connect two different robots. Yeah, if you are working within a single robot, then probably everything is going to be easier. But the moment you start trying to connect different hosts, then problems probably are going to arise. For instance, discovery failures. What does this mean? You are not able to see the topics of a robot from an external computer. Another typical issue is difficulty transferring large payloads. For instance, image topics, which are huge messages, point cloud messages also, which are huge. In regular DDS implementations, there are difficulties transporting these type of messages. Yeah. Also, issues transferring data over Wi-Fi. Yeah. Or even deployment complexity. Yeah. Because in order to have this working, you have to start creating complex XML files, and you need to know how to specifically configure them, etc. And many of the problems come because by default, ROS2 works in multicast mode. Okay. Then, in order to try to solve all these problems and make things easier for the users, for the developers, for us at the end, this RMW-Zeno DDS or middleware implementation has been added, has been created, and has been added to the ROS2 ecosystem. All right. Then I'm going to start by saying that RMW-Zeno can be configured in many ways. Even it can be configured to work with the multicast mode as the regular DDS implementations. But the default mode in which RMW-Zeno works is what is known as the Zeno router. Okay? And this is a concept that if you are familiar with ROS1, you can probably relate with the ROS Master URI and the ROS Core. Okay, it's not the same, but in order to get a quick idea, you can think of that. Why? Because you are going to have a Zeno router, which is going to be like the central point for discovery. Yeah, this Zeno router is going to be in charge of all the discovery in the ecosystem. Yeah, so it's going to be in charge to make sure that one node is able to see the other node, and so on. Yeah, but the communication between the nodes is going to be still peer-to-peer. Yeah, so the router, as I say here, acts as a broker for discovery data, and the ROS2 nodes communicate in a peer-to-peer mode. Okay, this might sound a bit abstract, but we are going to do a demo right now, which is going to clarify this. So let's open a new terminal sessions, and we are going to start right now a new simulation. Yeah, Then for this, we are going to source this workspace, okay? This workspace RMW0. Okay, one thing that I have not mentioned, you have it here in the notebook, but I have just gone over that, is that currently, in order to work with RMW0, you have to build it from source, okay? But I have talked with the developers of RMW0, and they told me that they are planning to release the binary packages soon also, yeah? But because of this, what we have done here is to basically build from source RMW0 in this workspace, yeah? So this is why we are sourcing this workspace here. Then, second step is to set the RMW implementation, yeah? In order to change the RMW implementation that ROS2 works with, we have to use the RMW implementation global variable, yeah? So let's change the middleware implementation by changing the variable, the environment variable, and now we are going to start the simulation, regular ROS2 command. There we go. Okay, so we are going to start seeing some messages here, and we are going to see a gazebo sim world appear, right? But if we pay attention to the terminal, you're going to see a bunch of errors here. Let me stop and read one. It says, unable to connect to a Xeno router. Have you started a router with? And the answer is no, right? We have not done this. So let's open a second terminal, yeah? And we are going to follow the suggestion by the error messages.
5 minutes.
Sorry? Okay, thank you. Yeah. Then in this second terminal, what we are going to do is repeat the process. We are going to source the Xeno workspace. Here. Let's source the workspace where we have built Xeno, and let's export as well the middleware implementation and set it to RMW Xeno CPP. And here we are going to start the Xeno router with the following command. Okay, let's do that. Now, pay attention that in the simulation, right now, there is no robot, okay? So actually, the only things that have loaded here are the gazebo-related things, yeah? Nothing related to ROS has loaded. The only thing that has loaded is the world, which doesn't depend in ROS, yeah? It only depends on gazebo, yeah? So as soon as I start here the Xeno router, yeah? If we go back to the first terminal where we started the simulation, we are going to see, let me scroll up here just a bit. We are going to see some messages here. There you go. Successfully connected to a Xeno router, yeah? And then as soon as this connection is made, all the ROS2 stuff starts loading. And if we go back to the simulation, we are going to see that actually our robot has appeared here, yeah? So now we have the ROS2 system working correctly, yeah? So actually we can open a third terminal here and run a ROS2 topic list, and we are going to be able to see all the ROS2 topics related to the simulation. Well, actually not as simple, right? Because if I try to do this, I don't see the topics. Why? Okay, I cannot see the chat, but I'm going to assume that everybody is answering because you didn't change the middleware implementation to Xeno. Okay, yes, and that's the correct answer, yeah? So by default, I am not using Xeno. So if I want to establish the connection, I need to source and set up the middleware implementation to Xeno, right? So let me do this. And then here we are going to be able to see the topics. All right. Now I can, for instance, run also a poop command in order to start sending messages to the command belt topic here. and we are going to see that the robot is going to start rotating. Yeah? You see? And now there is one interesting thing here. So what happens if I stop the Xeno router? What do you think is going to happen? Well, actually, I have just stopped the Xeno router, and you can see that actually nothing happens. Everything keeps working normally, yeah, and the robot keeps receiving the command belt messages and keeps moving, yeah. So why is that? Well, that is because of the concept that I have just introduced here, yeah. So the Xeno router acts as a discovery broker, yeah. So it basically only is in charge of making sure that all the nodes and topics are discovered. But the node-to-node communication is in peer-to-peer mode, yeah. So if I stop the Xeno router, the communication is going to keep working, yeah. And this is a huge difference, for instance, with respect to the ROS1 ROS core, because in ROS1, if you stop the ROS core, everything dies, yeah. So here it doesn't. Then this is a very simple setup, because we are okay. Maybe I'm not going to have. How much time we have left?
None. We need to finish, Alberto.
Okay, then let me just explain this in 1 minute, very quickly. Okay, the last part. In 1 minute, I promise. Okay, so here we have seen.
Start counting now.
Okay,
Go.
yeah. Very quickly, because I think this concept is interesting. Then here we have seen a very simple setup, because everything is running in the same hosts, right? But another interesting thing about RMW Xeno is that it makes the host-to-host communication very easy. So I had a demo here prepared, but I'm just going to explain it. Yeah. Then if you want to connect different hosts or different robots, all you have to do is to start one Xeno router in each, right? And then you configure each Xeno router to see each other. For instance, in the case of the Raspberry and the Roject, I can create a configuration file from here and point it to the IP. In this case, this is an IPv6. This is the IPv6 of the Raspberry, right? And in the other side, in the Raspberry, I would do the same, but pointing to the IP of the Roject, in this case, that I am working, or the other robot. And just like this, you can start in the Roject the Xeno router, and in the Raspi, the other Xeno router. Or this can be a computer and a robot or whatever, yeah, different hosts. And then with this simple configuration, you can have both hosts communicate between them, okay? So yeah, I just wanted to explain this. Here you have a very other cool thing, which is TF filtering in RVs, but I will leave this for you to check on your own. So yeah, I'm done.
Okay, excellent. Thank you very much, Alberto, for your excellent overview of the new features of ROS2 Jazzy. And yeah, so there are a lot more and many other things, but yeah, so we need to leave something for the rest, so that to be the people interested. So let's go now for the questions and answers from the audience. Remember that we have a tab on the chat on the side that says Q&A. You can put your questions there or vote for the ones that are already there. And then I will transfer the questions to Alberto. So let's have a look at the questions that we have already. One from Rigwit Rohan, that he says, can we expect a proper gazebo sim core by the construct in the future, because there is not a lot of resources tutorials available for the gazebo sim?
Yes, so actually we have one course on gazebo sim, but what we are lacking, especially in the construct, is to actually use gazebo sim in all our courses. Yes, so to actually update all our courses so that they use actually gazebo sim, because most of them still are using classic ignition, yeah. But we do have a course on Gazebo Sim there. I think it's named Gazebo Sim with ROS2 or something like that. Maybe somebody can share the link there. But yeah, for sure. So taking into account that Gazebo Classic is not going to be supported anymore from now on, then all the new material that is going to be generated is going to be using Gazebo Sim, basically. So yeah, you should expect much more material coming on Gazebo Sim.
And one question here from Sebastian Castro that says, what was the RMW Zeno CPP package installed from source? Because it's not yet available from binaries in Jazzy or something else. So what did you do?
Yeah, exactly. So the RMW Zeno has been built from source in this project. Okay, you are going to see it in this workspace RMW Zeno, and currently this is the only way in which you can install it. Okay, so if you want to use this middleware implementation, you have to build it from source. Okay. Now, I have talked personally with the developers of this. We have a very good relationship, and they told me that they are already planning on releasing binary packages also quite soon. They couldn't give me an exact date, but it's going to be soon.
Okay, another question from Anderson Nardin. He says, from some time, Linux was the standard operational system for robotics. So do you believe that ROS versions which are compatible with Windows will make it more popular? Do you think that this is the standard for future ROS versions to run into Windows? What do you think?
I'm not sure. I'm not sure. I would say that no. Why? Because most of the developers are working with Linux. Then the possibility that you can install ROS2 in Windows is cool, but I think that in order to make ROS2 available to many more people, let me put it this way. I feel that it's going to be more important to use maybe tools like Docker than actually being able to install ROS2 in Windows. I think it's going to help for sure, but I'm not sure if it's going to really make it's going to be a game changer, let's say, that ROS2 is supported on Windows. I don't know, maybe I am wrong, but from my experience and from what I have seen so far, I have seen almost no people using ROS2 on Windows.
Okay, then I think that we are going to stop here the questions because now we have to go to another section. But thank you very much, Alberto, for this. But don't leave the stage.
Yeah.
Don't leave the stage because you're going to be the one to test the Limo Challenge solutions that we have received. So, but before that,
don't forget to rate Alberto, though. Thank you very much for your presentations, Alberto. Don't forget to rate the last speaker, Alberto, for the presentation of the best speaker of this year's conference. And yes, it is time, guys, to move on to testing the Limo Challenge.
Yes. Okay, so Alberto is going to be the master of ceremonies of this.
Yes, so let me maybe share my screen again, right?
Yes. So we are going to need, Alberto, to share your screen so we can see how you are testing the project. So from all the projects that we have received, there has been one selected at random. We are using a random generator, and then we receive the project. Who is this person?
Can you see my screen?
Yes, we can. What does it say there?
It's from Ashish Barma.
Okay, so Ashish Barma.
If he is there in the audience, please write something in the chat so that we know that you are here. Then I'm going to just run it. I have just copied the link that he has shared with us through the email, and yeah, I'm running it right now. So
yeah. So what Alberto has received is a link to the project of Ashish that contained the solution for the Limo Challenge, his solution for the Limo Challenge. Now, Alberto has now a copy of Hashish's project, and it's opening also in the cloud. Then Alberto has access to the Limo real robot, the one that we show you at the beginning of the conference. So what he's going to do, Alberto, is to run the code of Ashish in the real robot instead of the simulation. So Alberto is going to open first the project and then connect to the robot. And this is a feature that it's included in the construct, so you can put your project and connect them to the robots that you have. So by doing this is very interesting because in this case, you can have several projects from several, let's say, students that are can be connected at the same robot at different times, of course, but using a very simple process, which is going to be shown by Alberto. Maybe if we can see his screen.
Can you see my screen now?
Yes. No, it's not it's because of the transmission condition.
Okay.
So
let's have. This is almost finished loading.
Yes, it's loading the project, and that would be the process. And then we have Ashish Pama on the chat. So Ashish, can you share some of your knowledge or what is the solution? How did you implement it on the chat for us? Can you explain us a little bit in the meantime that the ROSet is loading? Let's see if Ashish can do it. And also let's see if the project opens. Yeah, I think that you have the previous project was very large, right, Alberto?
Yeah, it was.
It has to save first and then now.
Yeah, I had some extra packages there installed and
Yes. Okay, because I think this project is not that large, the one of Limo, isn't it?
Okay.
No,
this one I don't think it should be so big.
Mm-hmm.
Yeah. Also, okay, there we go.
There we go.
Yeah. Also, I think my computer was starting to lag a little bit, so. But yeah, now
no,
I think
it's okay. So it's there. So now the only thing that you need to do is to do the ROS launch. Yeah, well, first you need to connect to the robot.
Yeah, this is his project. So I hope that he has done something that it's not going to break our real robot. But let me just connect to the robot. Yeah, here.
Yes.
So let me turn on the connection, and hopefully we are going to be able to connect quickly and get the camera streaming here and see the real Limo robot.
Exactly.
The robot that you might be winning.
Exactly.
Depending on,
it's not the same instance because that instance is here. Oh, here we can see the lab, the real setup. Yes, and now this is in our facilities, and then the ROSet or Ashish is connected now to the robot.
Okay, so let me very quickly check. Okay, so he has something here, the back. Okay, I'm going to run the command and...
Yeah, and then everyone, we are going to see what happens with the robot, okay? We'll see. Please, the emergency team that is in the facilities, please keep... Yeah, I can see the emergency team legs there on the image. Be aware that we are going to launch it.
I was looking for the command.
Yeah, the command is on the...
Yeah, this is the moment of truth. I'm even nervous. Jesus. Okay, so let me run the command and let's see what happens.
No, that's not. This is not.
Not?
No, the command is on the instructions at the beginning.
This is simulation.
Yeah, this is the simulation. So the command is on at the beginning of the instructions.
Oh, the beginning. Okay.
Yeah,
okay,
it's a ROS2 launch. The package is, I think, Limo challenge. I think it is. No, on the instructions, it's on text. It's not.
Yeah, Limo challenge, start challenge.
Yes, exactly.
It is. Okay, all right, so yeah, let's go. ROS. Well, let me. Well, actually, the source is made automatically.
Yes.
But let me source just in case.
So that's the moment of truth.
To launch Limo challenge.
We have the emergency team.
The package is detected. Let me see. Yes, start challenge. The launch file is there, so let's see.
Package and launch file available.
I'm going for it. I'm clicking.
Yes, and there, emergency team is prepared, is ready to catch the robot in case that it just goes.
Okay, so
it goes crazy because that can happen.
Happening. Wait. The robot is started moving now.
Yeah, okay. Let's have a
Okay.
look. It's rotating. Okay, rotating is not a good strategy.
Oh, no, it's going the other way
And
around.
the other way. Okay,
Yeah.
okay. Okay, so still running. It's rotating to the other side.
I
Okay,
think this
crashing.
program is. I think it's making random rotations, based probably in timers or.
Okay.
Yeah.
Okay, so it crashed against the wall, right?
Yeah.
Yeah. So, sorry, but we have to disqualify this one because it's not actually solving the problem.
Okay.
Okay, then, yeah, so that's it. So, yeah, Rodrigo is indicating that it's not acceptable. So thank you very much, Rodrigo, for doing this. And thank you very much, Ashish, for participating and sending here. We have another project now that
Yeah.
you are
So
going to get. So you
going to
need to,
disconnect?
you need to disconnect. So we are going to try another one, and then we'll see. Okay. So we are going to see.
So yeah, actually, let me go.
So it's the second one that. Wait a second, because we can see your screen. Okay. So Alberto.
Okay. Yeah. Let me.
So now we are getting the link that is sharing the second limo that we are going to try. And I think that this is going to be the last one, because that's going to be taking a long time, and then we have a kind of 30 minutes for testing this. So it's going to be the last one. I think it's the one from Anton Duck, right?
From that, okay. I'm looking for the link.
Yes.
Just give me 1 minute.
Yeah. So you can have the link, and then once having the link, then you can copy by clicking on the link. It's a very simple process to share your project in this way, because just sharing a link, and then anybody that receives the link can have a copy of this. Actually, we can share the project of Anton Dag of for everybody have a copy then. So by the
let me reshare my screen.
Okay. Let's have a look what is happening there.
Okay, do you see my screen?
Yes.
Okay, so here we have Duck Development Project.
Okay.
Anton Duck, let's repeat the process. Let's run it.
Yes. So now we do the same thing. So he has a copy, and then
now we should load fast.
Yes, it should. It should. And then let's see.
Okay, so is Anton around the chat?
I don't know. Anton, yes, he is here. So he is listening. So Anton, can you share some strategy that you have applied in order to make the robot work?
Are you confident enough that your program is going to work, or?
Yeah, so let's see. So Anton mentioned that he has used the laser and the IMU in order to get the solution, and we are going to check the solution in a minute in the real robot. What is going to happen? And then he says the typical thing that every robotics developer says: it's run in the simulation.
Yeah.
Right? Yes.
Magical words.
Yes. Anton, we trust you. We trust you, man. Yes. But the thing is that the reality is too tough. But it is not in this case, because the simulation it's almost practically the same, and also the environment is not very difficult environment. So if it works in the simulation, it should work in the real robot. Let's have a look. In the meantime, that the project is loading. And yeah, so we are about to finish. After this test, we are going to see if we have a winner or not. Then otherwise, then we'll declare dessert. We'll talk about with the sponsors about what to do with this. So how to decide. So far, if it doesn't work, then we are going to stop. Now Alberto has loaded the project. Now he is connecting to the real robot also from inside the project of Anton.
Yes.
Best of luck, Anton.
Last chance.
Last chance. Let's have a look. Best of luck. Yes, I have the feeling. I have the feeling that it's going to work.
I hope so. Otherwise, I'm going to have to keep the robot for myself.
Okay.
Okay.
Let's have a look. So Rodrigo is on the spot and he is signaling, okay, you can start. Let's see the tension.
Okay. Yeah. Yeah, even the terminal is nervous. Okay.
Yes.
Launch.
Yes, you can hear the
It was Limo
bit.
challenge. And
Yes, start. I think it was.
yeah. Start challenge. Okay. There I go. Enter.
Okay, let's go. There it goes.
Okay, this is looking actually good.
Actually, it's doing the same thing as the previous one. So
No, I don't think so.
No? Okay. Let's have a look. It's first of all is evaluating the terrain, and then finally it's kind of let's see.
Because it did like a small turn to the left, like
Yeah.
it was looking for the laser opening.
Okay.
But
No,
yeah, no,
but
it's
it looks
more-
like. So what do you say, Rodrigo? Kind of stuck in there. So Anton says I do not. Maybe I think it do not have 360 degrees cran. And then he says maybe in the simulation it's saying that it's 360 degrees. Of course, Limo doesn't have 360 degrees, of course, because it's occluded upon some part. Then Andres says maybe you should compile it first, and it's not necessary. You can, but it's not necessary because it's an exact copy as Anton left it. So unfortunately, we are going to be declaring this prize as not achieved. And yeah, so that's, it was really was our intention and our hope to be able to deliver one Limo robot to the audience. But in any case, we are going to tell the sponsors what to do with this, and maybe we'll decide something. Please stay tuned in our networks and for any further decisions related to that. And now it is time to continue. So what's coming next?
So we have now reached the end of the session, and it is time to relax and enjoy the gala of the ROS Awards 2024. But before going into that, let us send a quick questionnaire about your opinion of the conference. If you're so kind as to fill it, it will help us a lot to make a better conference next year to suit your preference. So yeah, we're sending you the link right now, and let's wait for a minute while you fill the questionnaire.
All right, guys. So, yeah, successful conference, I would say.
Yes, we have almost reached the end.
We've almost reached the end. I
Almost.
feel good, I feel
I feel tired.
a little bit tired,
After 5 coffees.
for those
Only five?
for that European audience that is still watching.
Yeah, but
Thank you for still watching, because it is 2:20 a.m. But anyways,
But imagine the guys that are in Asia.
oh my
There were
God.
some people at the beginning of the conference that mentioned that they were going to go straight from 7 p.m. until 7 a.m.
Oh my God.
Wow.
Yeah, we try and always cover as many people as we can. Sometimes we do in the very early from very late. We do trainings as well to adapt to either the U.S. Time zone or this one, or Asian, not as much, but we will.
Well, Thisas says that it's 4:21.
Oh my God, Thisas wins. You definitely win, Thisas.
Nice,
So
nice.
some problems in the questionnaire. There is no permissions to access the questionnaire. So maybe
Let's see.
we can check this.
We'll wait for another minute.
Yeah.
Guys, let us know if you cannot access it. It loaded fine for me, says Ruben.
Yeah.
Thought you guys said you had 30 minutes. We did have 30 minutes. It loaded also. Yeah, it looks like you guys have. It's loaded, so
Yes.
awesome.
Yeah, on the polls tab. Okay. So we have the link also on the polls tab that it just appeared here. We have it. So you can also click in there and it should lead you to the questionnaire. So having the information from the questionnaire will help us to improve and to adapt the conference to your needs in the future editions. So that's very useful. You are helping us a lot in order to craft it for you. As you can see, so we have some errors and some things, but all the things that we are trying to provide you value all the time. So if you help us to know how can we provide you more value, then we'll do our best in order to accommodate that and provide you more value to you. So anything? So first answers arrive. Okay.
All right.
Okay, then I think that we can stop here and go to the next stage.
Okay,
What is
so yeah, we really appreciate all the effort that you guys made. So yeah, now let's watch an introduction video of the ROS Awards, and then we will announce the winners.
Excellent. Let's see.
All right, welcome to the 2024 ROS Awards ceremony. The ROS Awards are voted by the ROS developers community. The intention of these awards is to express recognition of excellence and achievements in the ROS world.
And we have to clarify one important rule of the ROS Awards, that previous winners cannot win again in this year, because that's not the purpose of the ROS Awards. So the reason of the ROS Awards is to spread the knowledge of the different people and technologies that conform the ROS community. So we want to give more chances to the more people so they can be recognized.
All right, so now let's present the Best ROS Software Award. The nominees are RVs2, Autoware, Behavior Tree CPP, and Isaac Sim. And the winner of Best ROS Software 2024 is Autoware.
Excellent.
Congratulations, Autoware, for being the best software. All right, guys. Awesome, awesome. So there we go, our first award. So now we can move on to present the second award, the Best ROS Robot of the Year. All right, guys, so this is an actual robot. So the nominees for this year are the Tiago robot, the Limo Pro, the Tortoise Bot, and the AMAB Bot. All right, guys. And the winner for Best ROS Robot of 2024 is the Limo Robot. Yeah.
Congratulations.
The Limo Robot is developed by AgileX, compatible with ROS 2, used for research and education.
Excellent, and one that we have been promoting here in this event. So excellent, congratulations. So now let's go to the final award, the one that you have been waiting for. I mean, all the others too, yeah, but that's the waiting for because it's the last one, so we can go home. Then the final award that we are going to present right now is the Best ROS Developer of the Year. And we have those following nominees: Sai Kishore, Tomoya Fujita, Gies Panderhorn, and Kashik Street. And the winner of the Best ROS Developer of the Year is Tomoya Fujita.
Congratulations, Tomoya.
Tomoya Fujita is one of the developers of Sony that is working in the Sony lab in the United States and is been the developer of several libraries for ROS, ROS 2, and especially working with Docker and Kubernetes technology integration with ROS 2. Congratulations.
Yes, congratulations to all the winners, and thank you for your contribution to the ROS community. So we will publish all the results to the public next week.
With additional data of statistics and so on.
Yeah. So, and that brings us to the end of the 2024 Robotics Developer Day online. So what an incredible journey it has been.
Wait. We haven't announced the best speaker of the conference.
All right, yes.
So do you have it there? Has been voted by the audience?
Yes, I just received the results from the central computer, and we're happy to announce the winner is Kimberly Maguire. Congratulations. So, yeah, Kimberly, you will receive a plaque with the award.
Awesome presentation, Kimberly. Congratulations. Well, excellent. That actually brings us to the end. We hope you have enjoyed every moment, from the expert career advice to the hands-on learning sessions, as much as we have. We'd like to extend our heartfelt thanks to all of our speakers for sharing their knowledge and expertise, and to our sponsors for their generous support.
Yes, and most importantly, we want to thank you all, the ones that you have been there, attending the conference, asking the questions, paying attention, and doing your best to make this conference as it is. And I would like to say that don't consider this as just a point that has been finished, but like a starting point, that where you can use all the knowledge, all the advices, all the experience that you have acquired in this conference to be like a stepstone for your next future. And we hope to see your jobs, your work, what you are providing to the humanity through your work in robotics. Then I think that this is all for the conference, and let's finish here.
And remember, the robots of the future depend on you.